Good afternoon, ladies and gentlemen. I am Anand Baswade, and it is my absolute privilege and pleasure on behalf of IIGFC 2023 committee to welcome you here today. We are delighted to see you join us as we gather for this IIGFC event. You being here on Friday afternoon is proof enough for your excitement to behold what follows. We have a keynote by Professor Rajat Muna, Director IIT Gandhinagar, and invited talk by Dr. Subhi Chaturvedi, Senior Global Vice President in MOBI, and some exciting paper presentations. I would now like to introduce Professor Rajat Muna, today's keynote speaker. Professor Rajat Muna is currently heading IIT Gandhinagar as Director. Before joining IIT Gandhinagar, he had served as Director of IIT Bhilai and Director General of Center for Development of Advanced Computing, CDAC. He is also a faculty member in Department of Computer Science and Engineering at IIT Kanpur. He, along with his students and colleagues, has authored 18 patents, several research papers and books. Professor Muna holds a BTech in Electrical Engineering from IIT Kanpur, 1981 to 85, and PhD in Computer Science from the Indian Institute of Science, Bangalore, IISc. His research area spans over embedded computing, computer security, VLSI design, and operating systems. He has been instrumental in defining some of the key applications for the country, such as smart car driving license, vehicle registration, e-passport, electronic toll collection, mobility card, etc. Professor Muna is an active member of the Technical Committee of the Election Commission of India for EVMs and has been instrumental in defining the EVMs and VVPAT. He has also contributed in defining the National Voter Service Portal and National Electoral Service Search for Voters. Professor Muna is the recipient of several awards and recognitions, including Indo-US Science Technology Fellowship, Poonam Prabhu Goyal Chair Professorship, Vasvik Award for the year 2010, ESA Techno Visionary Award 2014, Fellowship of Maharashtra Academy of Sciences 2015, National Award for Election Commission of India 2016 for the best electoral practices, and most recently, a special award for IT initiatives by the Election Commission of India in 2022. Without much ado, I now hand over the mic to Professor Rajat Muna for the keynote talk.
So first question, are my slides visible? Oh, wonderful. Okay. Let me first of all say that India Internet Governance Forum, IIGF, is a very appropriate vehicle for taking care of internet governance, how internet should be moving forward, what are the kind of technologies that can provide advantages to internet users in general. And this is basically an intergovernmental forum under UN body called IGF, Internet Governance Forum, and an Indian branch of it is India Internet Governance Forum. India Internet Governance Forum decided to hold a conference, an annual feature, basically to support academia and knowing about the research that is happening in academia. This is the first edition of IIGFC, and it is going to be an annual effort. My topic today that I actually want to present, I want to talk about is uses of internet primarily as a compute engine. Now, that's a very interesting thing that is likely to happen. So I thought I will actually first discuss this. Let me go to the next slide. I don't know. I don't seem to have the slide control with me. Can somebody? Okay. Yeah, got it. So if I look at this, in general, the compute technology, we can kind of put it up into three different categories of 20 years each. First, technology uses was primarily for data management. In 70s and 80s, you would actually put the data into your computer, look at the data, do a very quick retrieval of data, understand the data, databases, and these kind of things. And that's how the data management layer or data management was primary usage of computing technology in those 2 decades. Subsequent to that, 80s and 90s actually saw a big boost into collaborative computing, where computing would become a primary engine and people will collaborate to do the computing. Many large systems of computing came about that, and these were like developed in this way that people from various places can actually collaborate. Internet based software development actually came about in this time, and lot of open source activities and lot of activities by which people can develop these systems and all that and use it on their desktops actually came about this time. In fact, if you look at the one of the most famous operating system of our time, that is Linux, actually came around this time. The last 2 decades have primarily been seen as a intelligence and applications. So this is an era where applications became more and more intelligent, and AI and such kind of things have started coming in. Use of computing for deriving intelligence, taking policy decisions, taking decisions based on large data actually came about. And this is also a time when giants like Google and Microsoft and such other people actually came about, Yahoo and others, and started providing data related services, whether it's email or storage or whatever. Okay. So if I actually look at these 3 generations, this is what I see. The first generation is data management generation, which was basically, oops, I'm sorry. Okay, animation is not working, but let me look at this. So first thing was computerization of data, generation of reports, archival and quick indexing. So you can actually keep your files based on variety of things. If there is a thing about health record versus income tax records versus academic records versus company records or whatever, you could actually very quickly index them and archive them and do a quick recall and also search through that. And this is how the main usage of computing was in first 2 decades or first 20 years of computing. Computerization of processes, internet growth, network that started coming, for example, in healthcare, doctor to doctor network. If there is a problem, the doctor can actually consult another doctor. Consultative approaches started coming in. In fact, this era also saw evolution of robotic surgeries, where surgeries could be taken place at one place, and doctor or the specialist may be several miles away and still performing the surgery with the same efficiency. Telemedicine came in, and patient doctor network. So these are like health related things that actually came about. If we look at the last era, all these technology became even bigger, and especially in last few years, things like education actually took a very major role. People like online coaching started coming in, online teaching started coming in, and that further got accelerated because of the COVID pandemic. But these are the kind of things that started coming in. Things like doctor to patient network started coming in, where teleconsultation was possible. Patients can actually put in their problems to the doctors. The patient can put their reports to the doctors. Patient can do X-ray and medical imaging, consultation with the doctors, can provide such reports, such medical imaging and these kind of things, and can actually do more like real life experience, where doctor can guide them and say, use your camera on this side or this on that side and these kind of things. And teleconsultation or basically became a big thing. Now, what happened because of that? intelligence started coming in. Medical images are going from one place to other place. Maybe in the background, a software solution could actually look at this medical image and find out if there is an X-ray showing a fracture or not in the bone, or if there is a MRI image in which some problem is shown or something. And these kind of things could be discovered right on the fly. Personalized education, personalized medicines, personalized things started coming in. Realities, augmented realities, virtual realities, and these kind of things have started coming. A lot of AI started coming in. Now, all these things actually also needed a network to be part of the computing infrastructure so that one could actually pass on these information over a reliable and a fast communication network to the other side, maybe to the doctor or to the consultant or whatever. Now, if you look at today, I think internet is the primary backbone for any kind of computing. While computing does require processor, but I think more importantly today is the internet. In fact, we look at our compute infrastructure has not been changing as rapidly as one would expect it to be, but our internet bandwidths are rapidly increasing, and things are actually becoming lot much more dependent on the communication bandwidth. So modern computing, whether collaborative or not, is highly dependent upon internet. Even if you have to maintain your appointments on Google Calendar, you need an internet. You need to actually look at your emails. They are typically over internet and not really on the local area network. So things have started changing a lot. Um, Applications such as navigation, when I go on a car, my navigation map actually shows me the path. These are the kind of things which cannot work without an internet. I look at one place to another place, and this kind of a path finding and all that is actually carried out not at my local computer, which is my mobile phone, but maybe on the back end at Google servers, and the information is given to me. Education, once again, finding out what kind of text to combine together, what kind of experiments to combine together, what kind of assignments to do, what kind of other kind of things to do, is again, most of computation is actually happening in the back end, whether it's a virtual lab or whatever. Meetings is another classic example. During pandemic, online meetings, virtual meetings have taken the front seat, and even this particular conference that I'm meeting and I'm giving my talk is through a virtual meeting. So meetings have become a very, very important tool. Once again, cannot be done. This kind of computation, this kind of applications cannot be done without internet. Healthcare, I already talked about. Both healthcare and consultations have largely become internet driven. And a very important thing that has actually come about is payments. India is actually leading a very big payment system in the world, and most of the payments today are actually done online, and very rapidly they are done. So the way this country has leapfrogged into the payment system is enormous, and it has been all possible because of the internet, which actually became the backbone of all such applications. Now, if you look at the challenges that internet poses, not that the internet actually is free of all problems, um, languages still remain a big issue. Uh, if somebody needs an information in Hindi, it is possibly little easier today, but it is still not the same pace as that provided in English. If one needs information in Bangla or Marathi or Gujarati or Oriya, the challenges are very many. Literatures, the content is not that much available. The input tools are not that much available. The processing tools are not that strong, and therefore most of this governance being done over internet is kind of difficult to do over uh, over internet or over computing. On the other hand, um, e-inclusion, which basically means bringing every person of the society, every class of society on the internet, is still a big dream. Old people, parents, grandparents, they still have a big challenge on navigating through the compute system, and that's a big issue. I mean, how we can actually bring those part of the society, the aged people, the people who are hard of hearing, people who cannot see much, physically physically challenged people. I mean, how can we bring them onto the same network? At least in the civil and infrastructure, we know today that bringing everybody onto the same platform is not that big a challenge. It still remains a challenge, but is lot lesser than what it was 20 years back, for example. But in digital space, it still remains a big challenge. Fraud protection, getting spams, getting phishing mails, getting malwares is a very big thing, and often vulnerable people are found lost into this entire thing, sometimes losing money, sometimes losing effort, sometimes they are prone to blackmails and such kind of things. This is a big issue even today. Society needs to change this, and the corresponding enforcements have to actually become stronger and stronger. Even the technology have to become stronger to detect such things. Awareness against safety and security is actually a very big thing. Both computer safety, physical safety, and security of data is very, very important. A lot of data that is kept on the computer, if it is leaked out, it can actually have very lasting effects, and therefore there is a problem on that kind. I think another big problem is children exploits. Okay, there are these scammers who actually use the children, connect to them, go on to the chat or social media and such kind of thing, and exploit children using blackmailing techniques, and they actually can get a lot of things done through those children. This is by and large a very big problem in the world today. When I get an information over internet, whether I can trust that or not is yet another problem. We keep hearing a lot of social media platform, a lot of so-called news keeps coming, which turns out to be all fake, and therefore the trust that we actually have on information is rather low. And yet these kind of platforms actually have a tendency to make things much bigger and much more damaging than anything else. Technology jargon, I think is less said is better. There's so much of technology jargon. Often people like us are to be blamed for this, because the jargon that we actually praise to the people are often confusing, and they create a humongous amount of issue among people. So therefore technology jargon itself is a big problem. A classic technology jargon is artificial intelligence, where it is actually said that, and often people actually compare artificial intelligence with the natural intelligence, and it said, can computers and robots become as human as possible? Now, this is a classic problem where it is not understood by most people, saying this jargon is actually making it feel as if computers can overtake people. Now, that's a thing that we probably need to kind of work on some way and make this look better. I just looked at the global internet speed and a projection of that. See, global internet speeds, if we look at, are today kind of ranging around 100 megabit per second on an average. A person can actually get, that's the total wired bandwidth divided by number of people, comes to around 100 megabit per second. And it is only going to grow. 100 megabit per second bandwidth actually gives me a very interesting ways of doing video on demand, for example. And today Netflix and all such things on the mobile actually are testimony of that, where one can see any kind of video at any point in time, movies or whatever. Now this is going to become even stronger, and possibly with the bandwidth increasing, even things like 3D avatars, and you're talking to these 3D avatars and all that, really having a better feel and all these kind of things, are going to become a humongous thing in the time to come. Our bandwidths are expected to reach gigabits few years from now to 10 gigabits. Even if they go linearly, they will probably go of the order of about 10 to 20 gigabit per second in few decades. Now, if this being the case, the network bandwidth actually provides a very big opportunity of transmitting data across. And if that is the case, then one can actually think of um, endpoint devices like mobiles and laptops and all that, in a major way supported by internet bandwidth to be able to transmit things from one place to other place. And what kind of opportunity does it throw? So it throws things like uh, a very powerful computation to be done on the backends. So with powerful end devices, the computation model itself is going to change in time. Computing itself has been there in the distributed manner for a very long time. It probably is going to become even more distributed, and in time to come, it won't matter where you're computing, whether on a local system or on a backend. Lot of applications, lot of apps that we have on mobile phones today actually do good amount of computation in the backend. For example, when we actually look at some of these image processing tools and these kind of things, many times the computation actually for complicated image processing actually happens on the backend, and results are provided on the front end, and therefore the end devices will probably become in time to come largely a front end and very small computation for providing the presentation layer. It's a small computation but yet pretty powerful computation, and it will also provide a little bit of storage for storing keys and security elements and basic elemental data and these kind of things. On the other hand, backend will actually do bulk and expensive computations, like image processing, large scale image processing, identification of people, identification of culprits, doing situational analysis, doing audio analysis, creating biometric mechanisms, or doing 3D avatars and these kind of things, and even scientific computing for that matter, weather modeling or any other kind of structural modeling and these kind of things will probably start moving towards the backend systems. And backend systems will do large, bulk, and expensive computation, maybe on a subscription basis, maybe on a compute use basis, and therefore computing will be in form of public clouds providing the computation engines and applications, and data being there at the front end devices, collected at the front end devices, sent out to the computing, and results being displayed once again onto the compute devices. Of course, quite a lot of consolidation and aggregation will take place on the mobile device or on the front end device. Compute systems can be, for example, at TSP, telephone service provider, or internet service provider. So in fact, the role of telephone service providers will change drastically. In my opinion, telephone service provider will start owning data centers for providing public cloud services, and internet and Idea and BSNL and Geos of the world will start providing not just the telecom services, but apart from telecom services, even the compute services. And one would actually take a connection on an ISP based on what kind of compute infrastructure will they be providing. And access to these compute services will probably happen through end devices. And this is the possible future scenario. In this possible future scenario, internet is going to become a big thing. And therefore, if I go back to some of my previous slides, these challenges will become even more prominent. Doing computation in the language of people, doing computation such as language processing, natural language processing, where I speak in one language and it is resulted or kind of converts into another language. I speak in German and computer converts it to Tamil. thereby enabling a Tamil person to communicate with a German and vice versa. This kind of a thing will actually make even a better connected world, and more expertise will probably benefit the people from those places which were kind of left out from these kind of technological advantages. Languages in terms of spoken languages, languages in terms of written languages, languages in terms of, for example, is it possible to translate a written statement in Hindi to, let's say, so it's basically will require a huge thing. Written thing is done with the optical character recognition into language as a text. That language as text goes into a translation system to translate from Hindi to, let's say, Korean, and from Korean it goes into speech, from text to graphics, and then displayed on the screen. And that way Indian person, Hindi speaking person, can actually talk to a Korean person who speaks Korean. Now these kind of things actually are possible. If Olympic Games are organized, the commentary maker in that language gives out a commentary in that language, and which is then relayed all over the world in the language of people in that region. This is a remarkable thing that may actually happen with the internet being in picture. Now these kind of things, as an internet, we need to bring in. Internet needs to be robust in terms of supporting languages. Internet needs to be robust in terms of technologies which can convert from one language to another, and such kind of things. E-inclusion, I already talked about, and this basically means disabilities in terms of languages, disabilities in terms of comprehensions, disabilities in terms of physical mechanisms, disabilities in terms of subject understanding, and all of these things put together. Can people be made to communicate with each other? Can, for example, a computer science expert talk to biologists and start still talking about computer science and they would understand? Or a biologist talking to people in, for example, mechanical engineering, giving them large tissue culture applications and all that, and mechanical engineering is still being able to understand that, with variety of side material being displayed as one talks about. Fraud, if at all, is going to increase in time, and therefore protection against fraud is going to be another major challenge that will become even more prominent with the internet being omnipresent, internet being everywhere. And therefore these are the kind of things that one would actually talk about. So this actually brings large number of technological mechanism or technological reasons why internet is important and why internet governance forums are important. But I think even bigger a problem is going to be law enforcement, and that is a big issue. For example, today anybody can actually give out any voice over internet, and it can actually influence people. Now the question is it based on data? Is it based on facts? Or is it based on routine kind of things which actually creates rumors and therefore can create challenge to the society at large? And these are going to be problems that one can actually talk about, one can actually look at. Having said that, this basically requires a legal framework, this basically requires a technology framework, and this basically requires a social framework, and all of these three coming together to solve this problem of handling misinformations in various different ways. I think without going further, I will probably end at this point in time, and thank everybody for inviting me for this particular conference of India Internet Governance Forum. Um, and I'm eager to look at the presentations that will be made today. Thank you very much. If there are any questions or anything, I can probably answer them. Anand, you are on mute.
Yeah, Right now, we don't have any questions in the comment section. So thank you, Professor Rajat Muna, for such an enlightening talk and for setting up the stage for the rest of the event. Thank you. We now move on to the exciting paper presentations session. We have two sessions. In the first session, we have one invited talk and two paper presentations. I now invite uh, Professor Huzur Saran to chair the first session. Professor Huzur Saran is a professor in the Department of Computer Science at IIT Delhi. Prior to joining IIT Delhi in 1990, he did his PhD in Computer Science from the University of California, Berkeley in 1989 and a BTech from IIT Delhi in 1983. His research is focused on wireless networks, computer systems, and security and algorithms. He has served as the head of the Computer Science Department and the Amarnath and Shashi Khosla School of IT at IIT Delhi from 2007 to 2014 and 2015 to 18. He is currently the coordinator of the Center for Excellence in Cybersecurity at IIT Delhi. Professor Saran has been actively working in the 5G wireless technologies. He is currently a PI at IIT Delhi for the 5G testbed project funded by Department of Telecommunication. During 2000 to 2002, he was a visiting professor at the Information Systems Lab, Stanford, where he worked on the media access control layer of an early 4G wireless system. In the area of cybersecurity, he was an advisor to SolidCore, a software security startup, which was acquired by McAfee. Now, I hand over the mic to Professor Huzur Saran to chair the first session. Let the session commence.
Thank you, Anand, for the nice introduction. Now we have this session as already explained by Anand. And the first speaker is going to talk about trust in the digital age. How do you rebuild it? As you know, in the keynote talk just now, Professor Rajat Mona pointed about all the security risks and how to make things accessible even to the least and the last. So these are some of the topics Dr. Subhi Chaturvedi is very interested in. Dr. Subhi Chaturvedi is currently the Senior Global Vice President of InMobi and its Chief Corporate Affairs and Public Policy Officer. She also serves as the chair of FICCI Committee on Women in Technology, Policy and Leadership. She is a formidable voice in global internet governance and has represented India on internet governance forums globally. She has also served as a member of UN MAG Internet Governance Forum, appointed by the former UN Secretary General. Currently, she is also FICCI Committee Chair. She looks at improving access, bridging the digital divide to unlock the full potential of the JAM Trinity, an opportunity for women to ensure better contribution by women in nation building. When not building global coalitions for policy advocacy, she's an academician at heart, and her research interests include internet governance, emerging technologies, intersection of policy and industry, media and democracy, deepening democracy, and digital trust. She holds a PhD from IIT Delhi and 4 gold medals in mass communication, anthropology, psychology, and commerce. It's a great pleasure for us to hear her speak about rebuilding trust in the digital age, strategies for ensuring integrity and transparency in internet governance.
Thank you so much, Professor Saran. I can't thank you enough for the very generous introduction. I'm truly honored and delighted to be in your presence. IIT Delhi is my alma mater, and it's so wonderful to meet you virtually. It's an absolute delight and honor to be addressing this gathering. And I also thank Professor Anand and Dr. Jayajit Bhattacharya to give me this opportunity to share my views about a topic that I'm very, very passionate about. I'll just turn to my slides. And this is a conversation that it's not an option anymore. This is a conversation that all of us need to have when we're looking at ChatGPT taking over the world and how, and the AI, which used to be in silos, and it was this exotic thing that people would engage with, and they would basically say, hey, what is it that's possible, what is it that we can do, but not everybody had access. So what changed in the course of last, let's say, 3 weeks and now almost a month is the simplicity of the user interface made technology which was accessible to coders, the technical community, and gave it in the hands of users. And now you're seeing the use cases. You are seeing what is it that we can do, what is it that is possible through technology. You're also seeing what internet can do for you, right? So this is a conversation that we needed to have, that when internet is no longer a choice and it's in the hands of everybody, what does rebuilding trust, why is it that we need to rebuild trust, and how do you ensure integrity, how do you ensure transparency, how do you make sure that all of us, everyone who matters, everybody who's a user, also has a share of voice in internet governance. And as you can tell, this is something that I'm very, very passionate about. It's something that I'm very committed to. So what I've tried to do is make sure that we discuss the key pillars of trust and society integrity, and what does internet governance truly mean for us, how does it play out today, who are the key actors, and what is it that you and me can do to ensure that India's voice is heard, that our representation stays. And that's why I can't agree more with Professor Rajat Muna when he talks about the role that conferences and initiatives such as IIGF play, that this is the platform where India is no longer replicating technologies. This is where we are showing through the India stack and a lot of contribution that Digital India has made through all its three pillars. So when it comes to trust and society, I go back to Socrates, and I find a lot of value in some of the principles that he's laid out, that obviously, undoubtedly, one of the greatest philosophers who's framed the debate on trust and ethics. And now, about 2400 years later, what is amazing is that we are still discussing conversations around contextualization, what happens when the author puts out a text, or what happens when the spoken word goes out. And Socrates never wrote anything. He relied on students, and he had wonderful students, and it was a tradition of dialogue and debate, right? So now we are so worried about deepfakes, right? And this is where it's at the core of trust. When you look at various surveys across the board, questions are that globally trust has declined in institutions. So why is it that trust truly matters? And we integrate that with internet governance in just another 2 slides. But the importance of trust is when data is being put out. How do investment decisions get taken? How is it that the population decides to vote? How is it that people should care enough about democratic processes to stand in that line, to stand in the queue for 3 hours and make sure that they vote? And trust is a core building block towards strengthening community. Undoubtedly, it facilitates cooperation. So now, in Europe and across the World Economic Forum, and that's the context and the background in which we're having this conference, global leaders have gathered together at Davos. They're braving the winter snow, and they're discussing a newer model, saying not every country needs to work with every country. If they're ideologically aligned, if there is a trusted partnership, if there's a trusted relationship, that's where the balance of trade will lie, right? And DPDP has recently been published by the Indian government. It invited comments, and that's where the Indian government has also now talked about trusted geographies. We are still going to look at parameters, but this is the scenario in 2022. So it used to be like you can trust people or institutions or theories unless they've been disproven. But because of a variety of factors, now distrust is becoming this society's default emotion. And fake news concerns, especially when there's a pandemic. Remember, we're having this discussion in a post-COVID world where uncertainty became the only certainty. Overnight, things came to a standstill, and there was a lot of reliance in not just institutional or official sources of information, because things were developing at such a rapid pace, on informal sources of information, right? So how do you make sure that that world order that had been so carefully constructed by editorial departments of newspapers, everything had been turned on its head? So what we know for sure is business clearly needs to step up on societal issues. There has to be a greater contribution to public issues. You are not just a great leader from the private sector, if you're building a great profitable business. The ask is that what is it that you're doing by way of creating a brand with purpose? How are you engaging with new technology? How are you adapting technology? And how are you giving back to society? So this collapse of trust will also be at the heart of a lot of global democracies, right? So societal fears are on the rise. There have been job cuts all across, and technology has been one of the most important sectors, right? So when we look at now the issues of trust and how it plays out in internet governance, and Professor Mona spoke briefly to it, the three key levers are transparency, security, and access. And why transparency? So in the internet world, we are very fond of saying that sunlight is the best disinfectant. When decisions and meetings happen in very exotic locations where a lot of us, let's say people from academia, from civil society, they find these destinations very expensive. So now with the increase in online remote processes, the ability to engage remotely, UN meetings now have started allowing remote access and participation. But if you're not in the room, you're not in the room, right? Then if you're not at the table, you're on the menu, is something that we very fondly say. So this is where we need to start making more efforts. Every stakeholder in the stakeholder governance model needs to start enabling participation from other stakeholders. And there's a misnomer here that governments have disproportionate amount of access. Not really. Every stakeholder has their own set of struggles in a multi-stakeholder process, right? How much of access to information do you have? How many resources do you have at your disposal who will help you deconstruct the many inputs that are put out by a decentralized internet governance process? And then one of the key concerns is security. So everything, and we've seen so many news articles in the recent past that privacy and security is something which is disproportionately discussed, and rightly so. The constructs of disinformation and misinformation, it's a constant evolving process, cybercrime being one of the major issues. Saying, how do you really trust on a DNS website? How do you make sure that phishing is not happening? How do you make sure that somebody who's posing to create a URL or an email ID very close to what you are normally used to receiving? So how much of trust checks, balances, filters can we put in, especially for a generation that is coming online who are not digital natives? And then one of the biggest building blocks, which can be an enabler or a blocker depending on which country you come from, depending on how much of an investment we are making, is access. And when we say access, we do not just mean that can you get onto the internet? Can you use the internet in a manner which is safe, productive, enabling, where you are fully equipped to understand what does the internet mean to us? Does it just mean a social networking platform? Does it just mean a video sharing website? What are the geographic and socioeconomic disparities? So what we forget is, how do landlocked nations struggle with, let's say, access to a submarine cable? Where is it that they would submerge? How is it that they would ensure stability of pipes and sea cables? There's a lot of conversation that's happening today. And then there is a conversation on affordability, availability of local language content, and then simply the task of building capacity. And this is not just the government's responsibility, this is our responsibility, this is academia's responsibility. So that's where we need to make sure that our money is where our mouths are. When we come to internet governance, and here is the joy of looking at the internet. Our dear friend Professor Jovan Kurbula from the Diplo Institute talks about internet governance being a building under construction, which is always evolving. So when we look at understanding it, it was a loose set of rules, policies, standards, practices, everything that you require to make sure that you're coordinating and shaping a global cyberspace. One of the most interesting parts is the emphasis on internet governance, where it talks about multi-stakeholders, key actors, and their rightful roles and responsibilities. And this is where we need to have a very fruitful, long, consistent debate on what is it that each of these stakeholders need to do to ensure that our internet is trustworthy, it remains open, it remains permissionless, it continues to facilitate innovation. So some of the pillars that make sure that your internet remains trusted is how is it that your government, nation states are addressing issues like cybersecurity, digital trade, internet of things, internet governance institutions. Is your voice being heard there? How present are you? At what stage of decision making is your country represented? What is it that we're doing as a community to enable free expression? Is there space for dissent? What are the internet identifiers? Issues of privacy, and that is a road that's endless. It's never enough in terms of what is it that we can do which support reasonable expectations of privacy, and it'll also make sure that they balance in the need for innovation and disruption. And then always without a doubt the concerns around geopolitics of internet governance, and these are the key actors. So when we say that, who owns the internet or who runs the internet, it's very important to understand that the private sector has a role to play, but private sector and industries don't alone run the business. Otherwise you would just have pipes that carry content, that carry standards, that carry data. You also have a very important role which is played by civil society advocacy groups, educational groups, academia. You have the IETF that looks after engineering internet task force, that looks after technical standards, assignment of resources. Then you have intergovernmental organizations, the United Nations, Council of Europe, OECD, technical community, and national internet governance, as well as central emergency response teams. And this is where collaboration and enhanced collaborations between countries, friendly countries, where through informal channels you're able to ensure that look, crime over the internet today is transnational. It transcends boundaries. It transcends the power of sovereign states. And this is where more and more people to people collaboration, more and more CERT and government law enforcement agency collaboration needs to take place. So understanding that not everybody has an equal role, but they have an equitable role in internet governance. When it will come to issues of national security and sovereignty, the government will always make sure that they have a seat at the table and interests of its citizens are represented. But this is where each of us have a role to play, right? Not just thinking that, okay, we've done our job, we've made sure that we've cast our vote. So that's where through the conversation, and this is quite a mouthful, but I'll leave this slide with the people. But when Professor Muna was discussing about technicalities and jargons, so fun fact, I'm not an engineer, and I would always get asked when I was serving on these platforms, oh, too many jargons, how do you really navigate? Always ask, always don't be afraid, because civil society, non-technical groups, internet is not one single layer. It's got 7 layers, and that's where all forms of internet require consistent engagement from all possible sectoral groups. So the key actors are listed here. I-Star organizations have had a lot of role to play in how the internet runs, but the beauty is it's still a decentralized process, right? And if you look at the layers of internet, there are content standards, and I've broadly divided it into 3 structures. You have technical standards, you have telecommunications infrastructure, but this is really the metaphor for how does internet governance work, right? So you can look at any layer, you can look at it horizontally, you can look at it vertically, you can look at legal issues, you can look at socio-cultural issues, but it's like your house, right? If there's dampness or if there are termites, you have to continue to engage to make sure that this public good, this internet is a group of commons. We are making sure that we're engaging, we are ensuring that the community works with each other seamlessly, and you continue to participate and respond. And this was broadly the internet governance timeline, right? So from the IETF to standards being written to ultimately in October 16, which was a landmark event where the INA function transitioned from being a contract between the US government to the global internet community. And that's a huge milestone to say not one single country, not one single institution or organization runs the internet. So largely the internet governance landscape landscape across naming and addressing, local, national, and international and regional privacy development frameworks, education and capacity building. What do the users have to contribute as to how their internet will run? How do you hold large organizations accountable, right? Everybody has a stakeholder input process today. The good news is, I know it's never the same experience watching TV and being on TV in the studio and framing the debate, but you now have access to a remote process. So these are the headlines that we saw, just for context, right? The every single day newspapers, it's a critical asset. We understand, across health, across aviation, across banking, across finance, both state and non-state actors have been making sure that they're attacking critical infrastructure and resources. This is why we need to care about the internet. This is why equal amount of conversation needs to happen around defense, around education, around capacity building, around skilling more professionals so that they're trusted infosec advisors, so that they're part and parcel of every single organization, whether it's private sector, academia, or essential healthcare. So how is it that you and I can play a part, right? There are formal roles, and through the multilateral model, the Ministry of External Affairs, various layers of the Ministry of IT and Electronics, everybody plays a role. In 2013, India supported largely the bid for a multi-stakeholder model of internet governance, and they decided to actively participate in every formal and informal process. And now, since 2014, it's been a sea change where you've seen Indian government, the Honorable Secretary, Ministry of IT, is now on the high-level panel with Windsurf, one of the fathers of the internet, and India has a seat at the table. And that's a very, very important breakthrough, something that we need to be very, very proud of, where not only our voice, but the world is now looking at India for great models which are working in capacity building, which are working in you looking at use cases, how it gives you examples of how the internet can be a positive force mobilizer and a force for good. So what can you do? There are global roles and participation dialogues. ICANN has young ICANN fellows. It has several opportunities to ensure that you, as an academic, can participate, you as a young fellow can participate, and you start attending these meetings where they're even giving away fellowships to ensure that you're actively participating. Now let's look at the questions of integrity and trust. How do you build it? We have to ensure that processes are consultative. So the TRAI has a great, structure of taking inputs through public consultation. Even the first draft is done after consultation. You will then have open houses across the country. This improves transparency. This improves accountability. This also gives you an opportunity that your voice has been heard, a true collaborative approach, and you create a safe space saying, hey, I may not agree with the present draft, or I think that two other inputs can make it slightly more better. We understand it will always be a constant process. You can never get to perfection, but the idea of transparency and accountability builds trust. It ensures that the community is able to trust the final outcome of the draft, but also ensuring that the process is equally inclusive. So independent oversight bodies, transparent decision-making processes, and policies that promote accountability as well as transparency. And there is no harm in doing multiple iterations of the same draft. So what does that lead to, and what does trust in internet governance really mean? We're working towards the objective of a safe and secure internet, a culture of security, so that it's first and not an afterthought. And I know this is a difficult question to wrestle with. NIST in the US has come up with standards, and this is where the industry is saying that can we do more carrots and less stick? How is it that MSMEs and startups deal with increasing burdens of compliance and regulation? And that's where OpenStack, that is when innovations, that is when CDAC and a lot of government institutions as well as industry bodies, association and chambers are coming together to ensure that you're able to give toolkits to SMEs to make sure they're not completely vulnerable, right? You're only as safe as the weakest link in the chain. And then a very high thrust on public awareness and digital literacy. We cannot afford to have any single community or stakeholder group being left behind. And secondly, the thrust on responsible innovative models, right? Businesses which are from India that are looking at uniquely Indian problem statements in the internet. A lot of investment required from both private sector, academia, as well as the government across internet governance to ensure that you have investments, you have research problems which are delivering. You have to make sure that you're looking at even the right questions being asked. So this is where we proposed a collaborative approach where both industry and academia come together. We encourage multi-stakeholder governance. We make sure that you encourage active participation and you facilitate participation. So conferences such as the IGFC, where you have discussions on, hey, what are the institutions that I need to engage? How do I get there? How do I make sure that I input into them? How is it that I can be a part of the multi-stakeholder group? How do I build a credible track record of engaging in multi-stakeholder processes, right? And then collaboration, that requires true collaboration between private sector, public sector. And the most important task is, even when you look at investments, we don't look at a today, tomorrow horizon. The investors will always look at stable, clear policy and regulatory regimes. So they may be a little tougher, but they need to be predictable. And this is where consistency of inputs truly goes a long way in setting up a collaborative approach. And I wanted to end with these words. So I was a professor and I was teaching in Delhi University, and again, non-technical. But this is something where I believed about 15 years ago is going to be one of the most critical pillars of not just business, not just creativity, not just engineering, not just innovation, but the core to every democratic process. The internet democratized information, access, creation, content, creativity, knowledge sharing. So this is what I truly believe, that what is at stake today. Why is it that academia, specifically young research scholars and the youth, need to have a seat at the table? Is because you have both the internet freedom as well as our futures, collective futures at stake. So a consistent platform where not only are you engaging with academic research, but you're also looking at live problem solving, an ability to mentor as CDAC, as academic institutions, as NICSI, where you have a very vibrant culture of internet governance and engagement now, as to how you bring on a newer set of leaders who start participating and engaging in this dialogue, and ensuring that all of us who've been there, done that, start passing the mic around, right? So that's the ask. And we've been volunteering, we've been mentoring, we've been coming back to academia, and we'll continue to make sure that we hold up our end of the bargain. I will stop here, and again, very grateful to the entire organizing committee of the IIGFC, and many congratulations on this first edition. And we hope that we get to participate and see a lot more in the future. Thank you so much, Professor Anand, and very grateful to you, Professor Huzur Saran. It's been a true honor to share this platform with you.
Thank you, Dr. Subi Chaturvedi. Professor Huzur Saran, are you there?
Hello? Yeah.
Okay.
Yeah. So thanks, Subi, for a very nice talk. I think you brought out many issues, and on both the governance model, how it has improved as it has moved from the 2013 timeframe, from the contract with the US government to a multi-stakeholder forum, and how India has been able to get a very good stake in the whole process. I think that was very useful, and I'm sure the listeners would have learned a lot from your talk, and I'm sure they can. I don't think there are many questions. Anand tells me there are no major questions submitted, but I would encourage listeners, they can write to her or write to us at the conference, and we will forward any queries to Dr. Chaturvedi for guidance. I think she has a vast experience, and it will be very useful for young people who are interested in Internet's governance, and many of the other issues that were highlighted during her talk. Thanks a lot, Subi.
Thank you. Thank you so much, sir. Thank you.
The next speaker is going to talk about blockchain-based e-voting, a status update. So again, this is something Rajat mentioned earlier in his talk about how electronic voting machines are there. But now with the internet, the question is, can we actually do remote voting and make sure all the authentication, identification, and security issues are properly dealt with? It's one of those kinds of key cryptographic problems that have been around for a long time. And what's the status today? That's what Dr. Sauraditya Paul will talk about. Just let me introduce Dr. Paul briefly. Dr. Paul is an associate professor in the Department of Electrical Engineering and Computer Science at IIT Bombay. He used to work earlier as assistant professor in IIT Gandhinagar. He obtained his BE, MTech, and PhD degrees from Jadavpur University, ISI Calcutta, and KU Leuven. The PhD was completed in 2006. After that, for almost 14 years, he was working in many capacities as a researcher, looking at various data security research problems in USA, Europe, and Canada. Some of the groups he worked for was COSIC, KU Leuven, Computer Security Division, NIST, and CRI-SP, University of Waterloo. His work has centered on cryptography, data security, and related areas. Other than pursuing academic research, he has also directly participated in two major security projects in Europe and US. eCrypt eStream project, that was a European Union project, and the SHA-3 standardization project, which was organized by NIST USA. And presently, he is leading multiple Indian initiatives along with the Bureau of Indian Standards for standardizing blockchain-based applications under various ISO projects. So I look forward to hearing from you, Dr. Paul. Please go ahead.
Thank you so much, Professor Saran, for this very kind and generous introduction. And I'm also very pleased for the IIGF organizing committee for giving us the opportunity to talk about some of the important things that is going around us. Yeah. So let me first share my screen. Just a second. Where is it? Yeah. Okay. Yeah. You are. So how to actually so how can I actually make my slide visible here? Anand. Okay, present. Okay, all right, got it.
So you can share your screen.
Yeah. Okay. You have no slides, so Google slide, your computer. Okay, all right. Okay, I have to upload it, right? First. All right. Okay, that's fine. Okay, if I upload it, yeah, I think okay. Processing. Not very familiar with this platform. Okay. It is taking some time. Yeah. All right. Okay. Yeah. Okay. So I have been working in blockchain for around a decade. So in 2014, we have kind of trying to understand the firepower that blockchain has. Along this way, have been participating in various projects. So this is an opportunity for me to work with my student Arti to look at e-voting and when blockchain can be used for e-voting, just to explore as an academic interest that whether it is possible or not. So as we delve into the area, we found out that numerous papers have been published, and serious research is being taken up by various well-known researchers to see can blockchain platform be used to bring more security and trust into this platform. And it was not possible to accommodate all of them here, but I just want to give you a bit of flavor that what is the status in here. And I'm kind of sad to say that the status is not so rosy, but there are a lot of research going on. So nevertheless, that blockchain is a very powerful platform, so it makes sense to use this as a base platform on which to implement voting system. So just hold on your breath to see that. Okay, so first of all, we have used a lot of diagrams and graphics here, and those were taken very liberally from the internet sources, possibly without violating any licenses. So we thank all the designers of this graphics. Okay, without much ado, I try to jump right ahead into the main issue without talking about what is blockchain and what is voting, because I think that with 12 years being already we have spent learning blockchain, so everybody knows how the blockchain platform works. But the question is that why would you like to even we attempt to implement a voting system or protocol or application on a platform like blockchain. So what is the rationale? These days I think there is a huge amount of hype and provocation, especially among the young students or researchers who are new into this area, just that to find out everything that you have your hands on and use blockchain to implement it. So this may not be a very good idea in some sense, rather than it perhaps does a lot of injustice to the very important platform like blockchain if we try to implement a wrong implementation on the right platform. So okay, but the ambition or the expectation to use blockchain is not completely unreasonable. The reason is that as everything is going digital and online, so why not having a platform which is digital and more digital? Digital is not a very binary thing. It comes with a lot of shades. How much digital you want, how much physical part it should remain in order to provide more security and various other properties. So if it is human driven, so it is better to actually go digital. But one important point in this particular application that has to be taken into account is the automation. Why it is so? From the security point of view, we have learned a very important lesson that when you want a trust in any platform, and trust is very much necessary, humans are the problems. They don't create problems, they are the problems, because even if a human says the right answer, the truth, and he is fair, the other humans perceive that he may not be trusted. He should be there should be some amount of suspicion into this one, and that is where we say that you not only should be trusted and honest, you have to be perceived to be honest. So that is why this automation part comes into picture, that for some reasons, maybe quite rightfully so, that people trust automation. When we say that something is done by a machine, I have normally, in general, average people have more trust in this particular operations than if we say that something has some particular person has done this one. We probably want to see that okay, so let us try to see that whether it is trusted or not. So yeah, the automation part is very important. That is why going digital has one important aspect of it, which is important. And the secondly, And we need trust. And one point I want to highlight in the beginning, that trust and security properties are b- not same. I cannot say they are completely disjoint, but I would like to say that they should be treated in independently of independently of the other. Even though the security properties are there, we may not have trust. So there are various mathematical ways to prove it. For example, that security properties, especially the cryptography brings a lot of security properties into a system application we design. However, in 2010, when blockchain was discovered, and the entire industrial enthusiasm and the corporate sector as well as the government, all other various different sectors, they have jumped into this one as if it is a security good security platform. But security properties are already there earlier. The research is quite old, maybe around half a century. But what blockchain has brought into the picture, I mean, if you just try to extract the properties out of this fast blockchain based cryptocurrency, namely Bitcoin, is in this 5-letter word called trust. And this trust, if you take an abstract view of it, is trust is generated due to a framework which is called decentralization. So how decentralization and trust are intricately related, and which implies what, is a separate issue. But at least trust me for the time being that the ambition, or there's an attempt for using blockchain to bring more trust into voting is quite rational, just because voting is a operation, or voting is a transaction, voting is a game where the trust is a big issue. I mean, it doesn't matter that actually how you are trusted, but what is important that you project yourself to be very trusted. So how can you make other believe that yes, I'm trustworthy, I'm honest, and I should be perceived as such. So that is why it is important to have look for a platform where the human interventions into various things will be less, and automation will be more, and that automation could be put on a very trusted platform. And at present, one of the major trusted platform that we have is blockchain, so it makes sense to do this one. So now I even if we were able to put our voting system on blockchain, and trust has various flavors and shades. Another important issue that one should not forget is how much is off chain and how much is on chain. Normally the on chain computation and the storage is expensive. So as a practitioner of this art, we always suggest and recommend that if it can be done without blockchain, don't go for blockchain. So everything is actually divided into two parts: the off-chain computation part of it and the on-chain part of it. So that is also important, that are we actually having the on-chain or the off-chain one? Okay, so then I think my slide is okay. All right. Yeah. I see. Okay. Yeah. So now going straight into the technical part of our voting. First of all, I'm not going to give you a survey of an enormous number of blockchain-based e-voting systems are designed by various researchers, and every now and then they get broken. Rather than we try to understand that does it make sense to actually use e-voting on blockchain. So in order to understand it, I take an abstract view of uh, the uh, the number of protocols or the applications that are there, and try to extract out what are the common properties that we have. Very roughly, various papers have given various ways to implement e-voting in various use cases. But in general, if we try to look at it from a little bit of high level, perhaps it is divided into 5 phases. And this phase is subdivided into many other phases as well. So registration of the voters, and then the verification of eligibility, and then comes the casting of vote, and then you have the tallying, and then after that an important part is the verification that the counting is valid. That is very important in order to inject some amount of trust into this one. Now notably, notably you will see that I have put number 3 and number 4 into in bold. And why is that so? Yes, you got it right. The reason is that even though there is an enormous amount of attempt to have a fully functional blockchain based e-voting on any other available blockchain platforms, apparently the tallying is the most important part that is going into the blockchain automation. So if so, of course, quite rightfully so, because tallying is the part which is the somehow the basic foundation of any voting system. The security of the voting system crucially and most critically depends on if the tallying is correctly done or not. If you see the physical voting system, you will be able to know that this tallying is done by humans. So can we so this is the first attempt to actually outsource this physical way of tallying into automated part, which we technically call, has a fancy word called smart contract. So this smart contract is again the the most major important part where we may try to transfer the security intensive or trust intensive computation, and which is mostly the tallying. There are various things. In the 1 or 2 slides we'll be talking more about that. However, the registration, verification, eligibility, and very importantly the counting, whether the counting is valid, that is what is called the end-to-end verification. It comes under a lot of specific security intensive operations come under that is not quite successfully done. So that is why perhaps the where the blockchain is still not mature to have a large scale security intensive emerge as a security intensive voting platform. Anyway, so the main point here is the tallying part, and tallying means that the casting of vote, which is the easy part, that has to go into blockchain, and the tallying is also very crucial. So any blockchain which does not do tallying on its in its center probably should not be called a blockchain with e-voting. Okay, so now I would like to mention that across board, no matter in which application you create your e-voting for, some of the important properties are these, as the slide is showing. Integrity means that, I mean, the computations could be trusted. The eligibility, we already discussed it. Availability, I think it is self-explanatory. Fairness is a very important property, and very important property, and very expensive operations needed to even bring about something which is even some semblance of fairness, but a complete fairness and absolute fairness is still a pipe dream. Which means fairness means that the voting results will be published either to all of them together at once or none of them, because we would not want a blockchain based voting e-voting platform where before I am going to cast my vote, I come to know that which party is winning or which this is winning, and all these properties are taken from a very secure physical mode of voting system. So, and any digital platform that is unable to display one of the properties will probably have to think a little bit more how to bring them in. And the robustness is also, I mean, wrongfully people cannot alter the votes, and coercion is an issue which is very important, and some of us often believe that it is perhaps very difficult to implement using a digital platform. So okay, these are the properties, and there are various other properties. I have to be honest, and it was very difficult because every day we read new papers and we find that very different new security properties they bring in order to make it more trustworthy and something like this. Okay, so now in our draft paper, initially we have tried to categorize various that the intensity of security properties that we require in various voting applications. One has to understand, in order to actually tackle the voting issue and whether it could be really migrated into a digital platform, one has to understand that not every voting application requires same degree of security. For example, if it is a political voting system and if it is a national scale, you can understand the the enthusiasm and the hype, as well as the sensation that is created around it, and compared to something non-political. For example, in academia also, the students, the Senate selection and all these things do happen through a voting system, but they are not so much of nerve-wracking moments that we see in non-political systems. So so based on that, so one has to really understand that what kind of properties are more important based on the use case, that where what kind of voting is actually happening. So this is where we have designed something, and all these things are in the paper, so you'll be able to see in more detail when the paper comes in the proceedings. And I would like to give you some of the examples. Of voting, e-voting, blockchain-based e-voting systems. And the main takeaway from most of the proposals are that the tallying part will be done on blockchain, which is, I think, a big motivation to carry forward with the research. Because if it is self-tallying, that means I cast my vote and I don't depend on any human brain to see what is the result is, no matter how many people are actually doing it. I mean, this is the highly tense, this rooms, counting rooms are highly tense, and a lot of people. So this can probably be done with automation, and blockchain is a very good platform to provide it. So this proposal is using multiple blockchains created by multiple candidates. Because of the trust issues, I move on to the second one. That is, I mean, they created some contracts, and it is possible for any voter to create his own voting system and polling. So 3 contracts are created. Contracts are automatic self-executing program that the blockchain is famous for. And then we have another proposal almost like that, but here there are registrar and as well as an organization or a trusted third party, and they try to separate some of the information from each other so that anonymity is preserved. So this voting protocol displays anonymity, which is an important property in various cases. Yeah, also this is another blockchain based one. I think that all that you will be able to find out in the papers that were referenced. Okay, so yeah, so this is another one where the registration is done completely in a centralized manner, and then there is a voting smart contract. Once the vote is cast, this vote goes into this blockchain network, which comprises government, Origo, which is a Scandinavian government organization. So this word is also not Indian, and then the human resources. So these 3 constitutes the blockchain. So this is the architecture of one of the blockchain based ones. But I would like to, in the end, that I would like to do one thing, that this is a comparison of various properties. So you can see that none of them displayed all the properties in here. So fairness, yeah, so you can see that 17, which is this one of the. So the main thing is want to say is that even though these properties are quite inherent in our physical version of voting, various physical versions of voting systems, in a blockchain based platform, bringing all these properties into the table is a challenge, is a major challenge. So here I would like to mention one attacks, small enough, not much, that we have discovered in our joint study with my student Arti Dhiman. I would like to give you an idea that it looks like a long way off. We are a long way off in order to find a secure, very trusted platform. Here there is a blockchain-based platform called OVNet, which is almost like the decentralized database, and we are using some Diffie-Hellman based protocols to identity verification and self-tallying. And the steps are like this: you have set up, you have sign up, you have commitment is an important part of it, that you to bring trust, and then you vote, and the vote is done in a very interesting way, where we do some Diffie-Hellman style operations in order to cast our vote, and then we tally, and tally has to be self-tallying. Yes. So here, the very quickly, these are the voters, J voters, and this XI, these are secret strings that they have, and this box, this rectangular box, is the one where we put. This is done by the smart contract. So XIs are secrets. These are the voters, and this G to the XI, G to the X2, and G to the XJ. These are the values that the voters put in the blockchain. Blockchain means you can think of it as a monolithic black stone. Whatever you write, that date never stolen and nobody can delete it. Extraordinary property. The moment they have actually created it, the blockchain, the smart contract immediately computes G to the YY using this formula. G to the YY equal to, you can see the product of G to the I J, G to the XJ over the G to the XJ times I. Yeah, so this is the one. So they computed very quickly, and then the votes are cast, and then the smart contract very automatically computes this value, and this will enable us to find out who gets how many votes. The interesting part of it is you can understand that the most security where you need it is to computing, and you do not trust humans to compute it. So this can be done in an automatic way. So this automatic part, as I again repeated, that important part of important motivation for using blockchain. But the motivation is not enough. Okay, so now we see that even though this actually, I will give an example of 3 voters. They cast their votes. These votes are actually, there's a 2-party election. If you cast 0, that is for 1 party and 1. And then very interestingly, if it is G to the G square, we know that one party has got 2 votes, another party got 0 vote, and this has done using some mathematical nuances that is inherent in Diffie-Hellman style exponentiation that you see here, which runs on particular groups and mathematical groups and fields and some of the things like this, some fascinating mathematical objects. But one does not have to go into details of it, but this one. But how to actually attack it? It's a very small attack, but it still shows that people still should have less confidence into this one. So now, if we see that if we can change some of the x1 values very easily, because it is possible to make x1 change it to x1 prime, then the entire computation comes out to be the one that is in the last line, and the red part, if you see this in the exponent, is actually the additional part that you count. So now, if this part turns out to be something such the whole value in the exponent is less than the number of voters, then even though the voting counting is wrong, this will be accepted as a correct vote. So then I think that even though the vote goes on, but nobody understands that it is actually something bad thing has happened, and the voting outcome should not be trusted that much. So yeah, now this one. And also another point is that if it turns out to be less than the number of more than the number of if it turns out to be more than the number of votes, certainly there is a false there's an alarm that should be so that this falsification would be detected. But anyway, it is just a proof that we want to show that that a lot of research is still needed in order to come up with a really secure and trusted platforms. Okay, I now have to conclude that we discussed some of the state of the art, very high level state of the art, and some of the pros and cons of blockchain based platforms. And I think that serious research is needed in order to really generate a platform which you could trust. And I thank you so much. I also thank the organizer for giving us this opportunity to talk about this interesting subject. And thank you.
Thanks, Sauraditya, for a very interesting talk. As you say, that the key problem is in voting is how to preserve anonymity, fairness, as well as have a tally system which can be relied on by all the competing parties. See, so the question is, if you look at small meetings and committee meetings and other things like that, typically anonymity is not required. Right. Once you remove anonymity, right, then actually it's very simple. Then you don't need anything very sophisticated. Everybody can just sign their vote and say, I vote I vote nay, and everybody can calculate.
Then you don't require blockchain as well. Then you don't require blockchain as well.
Nothing is required. All you need is verifiable that I signed this. That's all. Which is digital signatures is enough, right? So the question is, anonymity is normally needed for large scale things, right?
Right.
When you're
Right.
talking about an election of a
Uh,
MP or an MLA,
uh,
that's the level at which anonymity typically comes in, right? For
yeah.
committee
Because
meetings,
it is a lot of tension. Lot of tension is out there because every small mistake you make, even if you did not make a mistake, they will jump onto you and completely rupture the entire system. So yeah.
right? So my question is, are any of the blockchain based voting systems at a scale where they can even be used for even a single legislative assembly election in Indian context, where there may be
I
a
have to
few
say,
lakh voters? Hmm?
I am not at all satisfied. I
Right.
believe
That's
that
the challenge.
that's a challenge. That's a serious
From a
challenge because in small.
computational viewpoint, even from a computational viewpoint, if you have a few lakh voters, right, and you have to design anything, you're doing Diffie-Hellman, all of that, can it really scale? I'm just wondering. I know what they.
It is not scaling up. I don't say that it scales. If you want, see, I have told you that there are say 15 properties that they need to that a voting system has to have. Max, suppose fairness, anonymity. Now, if you want to scale one property, then the fairness lacks. You lack fairness. Fairness means that it happens that what our experience is that if anonymity with cryptographic primitives and fancy cryptography like blind signature and zero knowledge proof are there, it make it a little bit slower. We can do it. It is doable. But the problem is that even if we use these cryptographic primitives to implement some of the properties, one important property it is very difficult to actually bring about. For example, fairness. Because we saw in our system that we saw that anonymity is there, then we saw that the last voter, they come to know the voting result ahead of casting the vote. So that is not a good thing.
Which
Even,
destroys the whole structure, right? Which destroys
because no, even if you decided to vote for say party B, why do you want to know that whether party B is winning or losing? Yeah.
No,
So
and it can impact the behavior of
impact very,
voters.
very
So
much.
that's why.
So that is why I think that is why our present motivation is that have a hybrid system. Let's not try to be very ambitious. Let's have a hybrid system where the very core part of it can be transferred into blockchain, and let us go ahead with the normal conventional e-voting or physical way of voting. But then also the question comes that uh, is it still worth it? This is the main thing. But in small scale, okay, for academic atmosphere, laboratory, fine. But for a practical thing, I think we are still a long way off.
So what you're trying to say, if I understand you,
Huh.
that suppose like in the Indian context we have EVMs,
Hmm.
right? So every EVM does its count just as it is done today, and then rather than the EVMs being physically transported, you're saying the EVM connects using blockchain and can
Absolutely.
carry information through, right?
Absolutely.
So that the counting process can be much faster and
Hmm.
much more reliable, right? Or something like that.
Right, right. What
Oh,
in the EVM respect, I mean, it is very very. Not very right. The research is not well baked, but still, apparently, it looks like that. Why? What happens when you take all the EVM? So EVM can be connected in a blockchain, so that the result could be the final tallying could be done in a blockchain. That part can probably be done, but now this is for the practitioners to find out that how much it actually brings. Even if I have a big blockchain network and connecting all the EVMs in various other
what is the
locations, and
value
then
of that?
what is the
And the
value of
point
that? The cost benefit. The cost benefit ratio has to be measured well. Blockchain has good properties.
right, right.
Yes, because if you
Okay.
requires a lot of money to do this one, and then it is probably not worth it. Cost benefit is the most important thing, I think, for any technology for it to survive.
Okay. Thanks a lot. I think it was a
Thank
very
you so much.
educative session, and I think the viewers must have learned a lot. And of course, Dr. Paul's webpage is there. You can write email to him if you have further queries on any of these things.
Absolutely, absolutely.
So thanks once more, and we can.
Thank you
move
so
to
much. Thank you so much.
You're welcome.
Okay.
So the last speaker in the session now is Mr. Maruti S. Inukonda. He is a senior PhD scholar in the Department of Computer Science and Engineering, IIT Hyderabad. working on privacy and security. He voluntarily contributes in architecting open source solutions for the IIT Hyderabad data center. One of these works earned him Best Cloud Innovator of the Year in Cloud Management from CCICI Cloud Conference. Before joining the doctoral program, he spent 14 years doing Unix, Linux systems, kernel programming in storage product companies such as Veritas, EMC, and so on. He contributed to a number of standards such as the SCSI standards and POSIX standards. He has 2 journal publications and a patent in storage software on Linux. In his free time, he does freelancing and mentoring at free and open source champs in upskilling students and professionals in free and open source software for data center use. He is currently holds an MTech in computer science from IIT Roorkee, and he'll be talking about internet access artifacts, balance between regulations and privacy, a threat intelligence perspective. Please join us, Maruti.
Thank you, Professor Hazur. I'm presenting my screen. Is my screen visible? Is my screen visible? Can someone acknowledge? Okay, thank you. So today, good afternoon, everyone. Today I'll be talking about internet access artifacts and which are used in both threat intelligence as well as internet forensics, and we'll see how we can balance between regulations and privacy of citizens or users from a threat intelligence perspective. So I'm currently working on this research project, and we deployed this one at an enterprise, not IIT Hyderabad, but an enterprise. And I am advised by Professor Bhimarjan Reddy and Professor Sparsh. Okay, so this is a brief agenda. We'll just see the motivation and brief background, and we'll see the regulations in India with respect to internet access artifacts. Then I'll just go through briefly our work that was published recently in CompsNet's FENS, which is a forensic enabled network computing environment. And we'll see how it balances between regulations and the privacy. So we'll also see 2 case studies, simple case studies like digital theft and crypto mining. Later we'll see the blind spot that are seen, that are basically noticed during threat intelligence and internet forensics. And we'll most end the talk with recent regulations that the Indian government introduced to remove these blind spots to help both threat intel and forensics. Then I'll briefly talk about our extensions to FENS to address these regulations. Okay. So we know that digital economy is completely powered by internet, and it's a most vital component of the infrastructure, and it helps in the growth of the economy. And there are actually many regulations for safety and security of the internet as well as the digital economy. But the crime rate, the cyber crime rate is soaring across India. So if you see some statistics from CERT.in, CERT is Computer Emergency and Response Team, who report crime incidents to respect to enterprise service providers. You see there were around 400k incidents in 1920, and that was a 194% increase from the previous year. Later it's continued to grow, and it will grow at almost the same pace. and that's what is the prediction worldwide as well. Now let's see a brief background about the internet so that we can all be on the same page with respect to the entire talk. So internet protocol actually works based on addresses, not the domain names that we type in on our browsers. So IP address is the internet protocol address, and end devices like mobiles, laptops, servers, workstations, anything at the source, that means at my end, are basically the IP addresses are private, in the sense they are not visible to the entire internet, and they are only private to the internet service provider or the TSP telecom service provider or even the internet and enterprises. We use all the service providers and enterprises use something named network address translation, where the private IP addresses are translated to public IP addresses, the assigned public IP addresses to these ISPs, and it's done in real time. So every time when a network transfer is done to the internet, so this translation happens seamlessly at the perimeter firewall come NAT device. So this NAT concept was introduced to address IPv4, the IP address version 4 exhausted because of its 32-bit namespace. So it was introduced for that purpose, but NAT has a good property. It actually provides isolation of devices on the LAN from the WAN or the internet. So this is a good feature from the security perspective, because it provides isolation to of the devices. But many people think that IPv6, so we don't need NAT. It's a myth, because even IPv6 also deployments also want to embrace this isolation. So they started using something named IPv6 translations. It's called NAPT, prefix translation. And so NAT is not going anywhere. So even with IPv6, we need NAT to provide isolation of devices. Especially when we have bring your own devices, users can have their own simple passwords like root 123. And we still, as a network administrator or network architect, so we have to ensure that the devices are still secure. So we usually use NAT. So, but NAT brings in challenges for CTI, threat intelligence, and forensics people. So we'll see those challenges. So in government of India introduced 3 artifacts, internet access artifacts in 2012. This was motivated by Intelligence Bureau asking, mostly from Kashmir region, saying that we need these NAT and IP addresses details of each and every internet access. This is akin to call detail records in telecom sector, where we used to get a monthly bill. If people know, BSNL bill used to come with a call detail at the end of the statement. Similarly, IPDRs are similar to CDRs, call detail records. So which contain the start and end time of the IP address, the source IP address allotted to a user, and which mode, whether it's a DHCP mode or static mode, it was allocated. The source IMEI is a hardware address of the handset or the device, laptop or a mobile, laptop or a workstation or a server. And the source network address translation is the record, which basically captures from which time to which time this source IP and a port combination has accessed this destination IP and destination port. And these two, translated source IP and translated source port, basically capture the public IP address allotted to the enterprise or the service provider. So that way, on the internet will only see, on the internet, only translated source IP and translated source port will be visible to the entire internet. So these are actually private to the LAN. So this combined with IPDR actually provides the user's identity. So after any crime, so a user can be pinpointed by looking up the NATSys logs, and then backtracking to the corresponding, using the source IP address, backtracking to the look up in the IPDRs, so we can find out the user. So these are very good from a forensics perspective, but so we also need to store that the regulations also ask the enterprise and service provider to record a PII record, personally identifiable information record, in hard copy. So so it contains the address, name, phone number, and then the contact number, email address, all personal details. So this is highly it's basically very personal data. So all these fields, I just want to emphasize that these fields marked with star are actually prone to privacy leakage. So these fields actually, the regulations never spoke about the privacy of the users. So there are actually two ways these artifacts will be used. One is during post-incident forensics. After a crime happened, the law enforcement agency authority will ask the respective service provider or enterprise for these IPDR and NATSys logs. And they may also ask access to these artifacts using a systematic manner for threat intelligence. Now the challenge is these systematically accessed artifacts can leak the privacy of the users. During post-incident, anyway, the privacy has to be revealed, but systematically accessed evidences basically can leak the privacy. So we'll just see a brief overview of our solution to address this privacy, but at the same time meeting the regulatory requirements. So this is a typical architecture of an enterprise network where we can see Radius DHCP servers for authenticating a user as well as the assigning IP address. And DNS server provides the lookups. So this NATCOM firewall server provides the NAT translations and the firewalling for LAN to WAN communication. Typically, a log aggregation server is used to dump all the records, IPDRs and NATSys logs. But this log aggregation server is basically not analytic friendly, and then the logs can leak the privacy easily. So we proposed a FENS, forensics enabled network computing environment, where we provide privacy at rest, and we store all the artifacts in a data lake house built using open source solution. And the data lake house basically stores the artifacts in a compact and analytic friendly format, and it uses the open source frameworks, many open source frameworks, and it's deployed at an enterprise. Let not be confused that it is deployed at IIT Hyderabad. And it does not, the FENS solution, it does not sit in the data path. That means there will be no performance overhead since we are doing additional data collection. So it sits in an asynchronous real-time path. It just processes the logs. And this solution actually also provides investment protection, which is basically a good thing from network infrastructure perspective. We don't need to do a forklift upgrade of these NAT firewall or any of these other appliances. Okay, so this is the architecture that we propose. So we have a continuous internet forensics appliance, CIFA, which actually takes logs and packet traces from these 4 network functions, and then it generates a privacy preserved artifacts which will be stored in a data lake based security information and event management cluster. So I'll see. So these are the artifacts that are recorded by FENS. As we can see, IPDR I have shown you already, and then source and NATSys log record. So in addition to what was proposed by the regulatory requirement, we actually added this destination fully qualified domain name, which is the website name or the web service name corresponding to this IP address. This is the name that we type in our browser, or when we when a service contacts another service, this is the name used, and it internally translates to this destination IP by the DNS server. So this is really important from threat intelligence and forensics perspective. In the era of cloud computing and even ever-changing names and ever-changing translation between names and IP addresses, this destination FQDN is a time variant field. If we don't store this one along with the artifacts, it can be very, very confusing and stale and incorrect during forensic investigation. So we basically store this destination FQDN also. So as I told, these are the fields which can leak the privacy of the users, and these are the fields that we added as part of our proposed fence. This is a setup at the enterprise that I told, the CIFA appliance, which is a 2U server having Apache Storm running in both the nodes in high HA mode. And this is a data lakehouse, which is used for storing the evidences in a secure and compact friendly format. It has HDFS for storing the data in a distributed fashion so that the queries can be run fast. And these are the primary worker nodes of the Hadoop HDFS cluster. So some results from our recent work. So we actually experimented lots of these half a dozen on disk file formats in HDFS to find out which are more efficient. So at the end of the results, we finalized using Apache optimized row column format, which gave better compression as well as the query performance. This line shows the query performance on this data. Since we are encrypting a few fields in the records, when we store them in columnar format, then all the homogeneous types of data came together, and it led to better compression. So that's the reason ORC gave the good results in our case. And this is the result shown per a week data. And if you see, we have actually in the enterprise, the data is collected from last 1 year. So in around December 25th, 2021, we started. So yeah, it's completed its already first birthday. So it took about 7.2 TB for last 13 months to store the evidences for an enterprise having about 3,500 users. Yeah, so this is the hierarchical format in the Hadoop file system to store that in a structured manner so that the queries run without contending on the directories or even the storage file system layout. So you can see here there are these many dates data, including NAT, syslog, and IPDR. We have about 365 into 2 times around that many days data. So these are so how do we balance between regulations and privacy? So artifacts captured by fence actually have only few parameters, the PII related parameters encrypted. We don't encrypt everything because it's all bits and we cannot make any sense out of it. So decrypted, these encrypted fields can be, we don't use anonymization because then we need to store the actual evidences also somewhere else. Instead of storing two copies, we prefer encrypting. So we use AES 256 CBC encryption along with a random initial vector. Then these evidences basically can be decrypted during post-incident investigation. The keys are stored inside the CIFA appliance. CIFA is actually a root of trust that basically provides the entire trust for entire this solution. So other parameters like destination FQDN, destination IP, these are actually left in plain text to meet the regulatory requirements as well as for threat intelligence. These help a lot, as I'll show in my case study. So what we are doing essentially, we are respecting all by ensuring that the privacy of users and citizens is ensured, and but we suspect all. So let's see some cyber threat intelligence case studies. One case study is from our standpoint, we believe that everyone is insider, not just enterprises. In case of enterprises, employees or even students, everyone basically is an insider. For subscribers, ISPs also, internet service providers also, subscribers are insiders because they are using private IP addresses. We believe they are insiders. And for the cloud service providers and VPN service providers, VSPs, VPN service providers, so a customer is actually an insider. And basically survey says network misuse basically accounts to 60 to 80% in case of any incidents. So we'll see these two case studies. One is the digital theft, which is related to movie, TV show, piracy, books, publications, and crypto mining, which is another threat from the digital economy perspective. So enterprise digital theft basically sometimes can cause reputation damage, and it can also cause huge penalties. If enterprise does not maintain the NATSIS logs, the enterprise has to pay from their pocket to for these penalties. Like example, some movie was pirated by an insider, then enterprise has to pay. For in case of ISPs and VPN service provider, they don't need to pay because they are treated as intermediaries and they don't need to pay. But for enterprises, this can be a serious cost also. So enterprises do have code of conduct, but it doesn't help completely. So to some extent it helps for ethical people, but for some people they actually continue doing the crime. We'll see how digital theft has been growing. So India ranks ranked fourth in 2020, and it went to third place in 2021 worldwide. These are the from surveys which are publicly available. And pirated content from the same Akamai report, it says it hogs 25% of the internet traffic. I'll be using digital theft and piracy interchangeably. And this hosting website to add to how basically piracy is continuing, because the hosting websites use automatically generated domain names. They keep changing the domain names quite often using an algorithm called DGA, domain name generator algorithm. And so this way they can basically change the domain name quite frequently, and perimeter firewalls will not be able to block them. So insiders will continue using these websites, and Google and search engines will happily find them based on the content. So people search the name, and Google does fuzzy string search and then shows up the domain name as in the first page itself. So people click that and then they continue doing the piracy. And so this, as I told, it can cause reputation damages. So this is an output from the enterprise where our real-time event processing job in the Storm cluster inside the CIFAR detects these malicious domain names. These DGA generated names are called malicious domain names. So this is MDD, malicious domain name detector, which has been running in that appliance. And so we can see here, excuse me if this font is not visible. Here we can see a data lake query showing a fuzzy string search using a very famous movie piracy website, Movie Rules. And this fuzzy string search is implemented by us using Levenshtein distance metric. And any score greater than 80, basically we found that all Movie Rules websites are detected without leaving anything. So you can see here, this is a month. In this month, this is monthly data. On 25th day of every month, I calculated, because the query will take a lot of time to find out entire month for an entire year. So I just took from year 2022, 25th day of every month, I checked. So this movie rules website, I found out counted all distinct destination fully qualified domain names. As you can see, per day, the movie rules is changing about 24 times in some max cases. So that means a firewall will not be able to catch this thing. It's a moving target. So what do we do? Basically, these websites basically have to be anyway. Even if we are not able to block them, the evidences are being recorded. So we firewalls basically, what we have to do is basically using this storm input, we basically block the websites, the recently found websites, using the firewall. If firewalls support, many of the firewalls do not support RESTful APIs to block these websites. So we are working on making this firewall API based thing so that we can block these websites in real time. And coming to crypto mining, so again, voluntary crypto mining. Crypto mining in India is not yet illegal or legal, so it's not defined currently. But crypto mining using enterprise resources for personal gain is illegal and unethical. So this is we recently discovered from the enterprise data set that there has been crypto mining happening from inside the enterprise, and people were using GPU servers for doing crypto mining for their personal gain. As you can see, these are the two famous crypto mining pools that were accessed this many times in the entire month for the entire year. Okay, now I'll conclude my talk with blind spots in threat intelligence and internet forensics. So we think that firewall can block all these or detect these websites, but VPN, people use conscious users, sinsters basically use VPN to escape from getting logged by firewall and the NetSys logs. And the malicious domains basically keep changing their IP address and domain name or both quite periodically, as we have seen in our query result. So this is these are the two blind spots from the forensic and threat intelligence perspective. What do we do? Indian government recently introduced in April 2022, they introduced some directions to VPN service providers, cloud service providers, enterprises, and even ISPs to collect logs similar to 2012 regulation. But this time, these regulations actually did not talk in detail about what needs to be collected. They are very generic. They are just guidelines or directions. And we believe that these directions are a need of the hour. From our experience and from our threat intel and forensics perspective, we found that these will surely help in removing the blind spots. But these regulations do not talk about privacy of the users. And as it is left to the owners of the service providers, but many VPN service providers objected that it is collecting all the logs is basically encroaching into privacy of their users. I mean, I too use VPN, but we have to be conscious that VPN service provider now is also under the regulation. And so many VPN service providers objected this regulation, and then they were asked to quit India. Now they closed their data centers and left India. So ensuring privacy is as per this regulation is left to the owners of the service providers. So we think fence can help balance both, even for cloud service providers and then VPN service providers. So as we can see here, as I told, fence can help both of them, privacy as well as the regulations. And ISPs, for ISPs actually do source netting, so fence will work. We have tested for an enterprise, but for ISPs also the existing fence will work as is, because they also do source netting. Source address will be translated to public address. For cloud service providers, they do destination netting. So we are working on extending this to cloud service providers. So they do destination netting. So and VPN service providers are little tricky. So they do source netting as well as destination netting. Source net is done for the outer IP datagram. Actually, what VPN uses a packet in packet technique. So an IP datagram will be encapsulated inside an outer IP datagram, so that inner IP datagram is tunneled without leaking the privacy. So for the outer IP datagram, source netting will be done at the VPN service provider's perimeter firewall, and for the inner IP datagram, basically the destination netting will be done. So this is the big picture showing if CIFA and DLSIM are deployed at these stakeholders, basically we will be able to remove all the blind spots and at the same time ensure privacy as well. And so that's all from my side. These are some references. Thank you.
Hello. Thanks. That was a very interesting talk, Maruti. And you have developed your own SIM, right? DLSIM is your own implementation, right?
Yes, sir.
And of course, ठीक है. So one question I had is, if you compare, instead of comparing with yours, first let's say, what are the top leading SIM vendors internationally and in India today, both open source as well as the commercial products? What do you think are the main ones?
So we basically built it as an experimental thing. So we didn't.
No, I'm just asking just so that later when we can start benchmarking. For example, ArcSight and other things are there. Splunk is there. Many kinds of SIEM platforms are there. What do you think? What do you consider the most best platforms out there? Because eventually you would like to benchmark your thing to that, right? It may focus on only some dimensions, but you want to be comparable to the best, right?
Yeah. So Splunk is what we have explored. We have taken some ideas from Splunk. Basically, so DLSIM is a reference implementation. So this concept of storing these artifacts can be integrated with Splunk as well, because Splunk provides very nice threat intel. The gap we found that is the encrypted fields in the DLSIM that we are doing. The Splunk is able to not decrypt them, so we are not able to integrate. So, these open source softwares can be.
They are not able. But is Splunk completely open source? Is it?
No, there is an enterprise edition as well as community edition. So.
Okay. Thanks. I think that was good. And if there are any other further questions, people will write to you. We will put your link on the site. And so with that, we come to the close of the first session. And I would hand it back to Anand. We are a little late, but I guess sort of these things cascade a little bit. We can't control that, but I think not too bad. Thanks again, everybody, for and I'd like to thank all the speakers and Maruti in particular for their very informative technical presentations.
Thank you. Thank you, Anand.
Anand? Anand, are you going to take over because I think now it is Rajiv Shori's session, right?
Yes. Thank you, Professor Huzur Saran, for chairing the first session.
You're welcome.
Now we move on to the next session, and I would like to invite Dr. Raju Shaurya to chair this session. We have 3 paper presentations in this session. Dr. Raju Shaurya is the CEO of University of Queensland, IIT Delhi Academy of Research at IIT Delhi. Raju serves as an adjunct faculty in the Computer Science and Engineering Department at IIT Delhi. He is an honorary professor at the University of Queensland, Australia. Dr. Shaurya received his PhD and MS in Electrical Communication Engineering from the Indian Institute of Science, Bangalore, India, in 1997 and 1991, respectively. He received his BE degree in Computer Science and Engineering from IISc Bangalore in 1987. Dr. Shaurya's career spans several reputed research labs: TCS Research and Innovation, General Motors India Science Laboratory, IBM India Research Laboratory, and Sasken Technologies. Dr. Shaurya served as the first president of NIIT University from 2009 to 2013 before joining the TCS Research Lab in 2014. Dr. Shaurya's work has resulted in more than 75 publications in international journals and conferences and several US patents, all in the area of wireless and wired networks. He has 13 issued US patents and several pending US patents to his credit. Dr. Shaurya serves on the editorial boards of 2 of the top journals in the area, IEEE Internet of Things Journal and Springer's Journal of Wireless Networks. His area of interest are wireless networks, including 5G networks, telematics, IoT, industrial IoT, IoT security, and automotive networks, including the intersection of AI and machine learning with communication networks such as IoT and edge devices. For his contribution in the area of communication networks, Dr. Shaurya was elected a Fellow of Indian National Academy of Engineering in 2007. Dr. Shaurya was received by ACM as Distinguished Scientist in December 2014. He was elected a Fellow of Institution of Engineering and Technology, UK in 2021. He serves on the Executive Council of ACM India and the Executive Council of IEEE ComSoc, Delhi chapter. Raju is the co-founder of 2 of the top conferences in India, ComsNet and AIML Systems. With this, I hand over the mic to Dr. Raju Shaurya to chair the session.
Thank you very much, Anand. Dr. Anand, am I audible?
Yes, yes.
Okay, great. Yeah. Thank you very much for that very kind introduction. And thank you, Professor Huzur Saran, who was chairing the session before I did. It's a great pleasure to be a part of this conference. We have 3 papers in this session. I was going through the title and the author. I think we have 3 very interesting papers now that are going to keep us busy in the next 1.5 hours. The first paper is the paper titled Trust Token Secure Application Framework Based on Indigenously Developed PKI Hardware Token by Dr. Dhiman Saha. And then we have, of course, the paper on blockchain in the following. The next paper will be on blockchain by Pragyan Gemini. And the last paper in this session is on dynamic SLA using smart contract for terrestrial and non-terrestrial RAN leasing by Mr. Aman Khan. So 3 exciting talks. Let me now request the first speaker, Dr. Dhiman Saha, who is going to talk on Trust Token Secure Application Framework based on indigenously developed PKI hardware token. I'm going to request the speaker to please be very conscious of time. Let us keep your presentation to 20 to 25 minutes. And let's keep the last 5 minutes open for Q&A. I mean, it'll be nice if we keep 5 minutes for Q&A. So please stick to your 25 minutes presentation time. Thank you so much, Dr. Saha. Over to you.
Okay. Thank you so much, Professor Shaurya. I'll share my screen. So can you please confirm if it is visible? Is it visible? Anand, can you please confirm if it is visible?
Yes, Dr. Saha, it is visible. Yeah, please go ahead.
Thank you so much. Thank you so much, and thank you very much for giving us this opportunity to talk about our recent project that we have been able to deliver. So as Dr. Shori had introduced, I'm going to talk about trust token. Okay, so I have already put this on the slide as this also a trademark. So actually, this is more of an implementation-based work that I'm going to talk about. So, and it's a joint work with a lot of authors, but I would really like to take their names: Darunjit, Aman, Professor Muna, Savita Ji, Manish, Brahma, Adarsh, Aditi, Ayushi, Venkat, Aninda, and Satanu. So it has been actually a multi-year effort behind this project. And I would like to emphasize that this is something that is purely made in India. And as we go along, I will show what was the reason behind this particular project, and also that this project is sponsored by Ministry of Information Technology, MITI. As you know, it's a part of the this R&D projects that MITI sponsors, and I'm really happy to be able to share this result and this product and this implementation in the India Internet Governance Forum. And I have a particular belief that the audience of this forum is going to benefit from the usage of this particular product. So let's start with the problem at hand. Actually this particular forum, I think, would appreciate it the most that nowadays with the adoption of the digital age, as we have moved on, as we have adopted, and as the digital age is more organic to us, like drinking water, being on the internet and using our mobiles and other smart devices, we are increasingly being vulnerable to a threat surface that's growing, right? And I think every day on the this internet, on the news channels and all other media outlets, we see this news coming in that people who are not necessarily very not illiterate, or not that they are not technologically conversant, but these people are getting fished, and they're succumbing to certain very unsuspecting things. Okay, and these attackers are day by day becoming smarter and smarter, right? And this actually tells us that there is somewhere a need for some kind of extra layer of security than what exists. Whatever exists definitely has evolved over time, and it is quite it protects us from many sides. But as the attackers are becoming more smarter, so we have to keep up in the race, right? So this is perhaps the problem statement, and the way I would like to stage this before I set the stage, before I would like to bring in what we are offering actually in terms of the new product that we have developed. So I think, yeah, we understand, right? There's online gaming and any other kind of things. These are very, very, very prevalent, and mostly what I would like to use the term is the insider attack. Insider means sometimes it is not that someone else is doing it; it's us who are clicking on unsuspecting links and becoming prey to these scams. So what about from the governance angle of it? Because this is a governance forum, and e-governance is definitely a term that is synonymous with all the government schemes and amenities that we take advantage of. So you can see that there is an increasing focus of the attackers towards government websites, government mechanisms, internet service delivery mechanisms that are there in place. And you can see there this some certain results and certain reports tell that there is as many as 30% surge into attacks that are aimed particularly at government personnel, government services, right? And this actually, and these are not like foreign publications, these are all Indian media outlets that are reporting this, and hence this puts us in the right spot to understand that there is definitely a need of something more than what we have currently in place. And when I talk about something more, I start with this idea of multi-factor authentication, which is known to us, and I think all of us who have used that ATM card would appreciate that a multi-factor authentication is what we have used, right? Because when you use an ATM card, you punch in your PIN. At the same time, you also use the physical, card, the plastic card, the magnetic tape, or the chip card that we use to authenticate ourselves. So this is multi-factor authentication, and if we try to classify it very broadly, there are other tools as well. Then we can put it in this way, which is very popularly known as what you know, what you are, and what you have. Authentication parameters. So as you can understand, what you know and what you have is definitely what you have used in case of the ATM card. And when you talk about what you are, this is necessarily our biometrics, like our iris or our fingerprints that we also use. For example, for Aadhaar authentication, many times we use this biometric information. So the idea is to mix and match this various parameters, various authentication verticals, so as to come up with more secure mechanisms, and specifically for critical utilities. So the word trust token that we have mentioned in the title of this paper, you could see that we talk about something known as a PKI hardware token. Now, this is a very broad term, and it kind of spans multiple disciplines, right? So when I talk about the word PKI, it stands for public infrastructure, which is actually a mechanism to handle public-private keys, the key management systems that enable us to scale in crypto in a way that is manageable, right? So that is the basic idea of PKI. And in fact, most of us today, if we are holding a government position or holding any position of authority, we are using digital signatures nowadays, right? And when you use digital signatures, most of us might have used these dongles that are available in the market. It's very cheap. You give a call to a vendor, you don't even have to leave the comfort of your home. You just have a online Aadhaar authentication, a video KYC, and they would deliver it at your doorstep, right? These dongles. And these, interestingly, these dongles, what is very exciting is to understand where these dongles are coming from, the hardware of the dongle, where is it coming from? The software part of it, the PKI part of it, is managed by the Indian certifying authorities, which is, the root of trust being somewhere like the CCA, the controller of certifying authorities, and then, which gives these rights to the sub-CAs or CAs like eMudra or, the other kind of, I think Panda CA. There are a lot of different CAs that are there, which, give these certificates and for digital signatures, right? And these dongles are a mere mechanisms to hold them securely, right? So dongles are a way to hold the private key corresponding to those, certificates that you use to sign a document. And remember, the IT Act of India makes your digital signature legally binding, right? So you cannot deny. It gives you the undeniability. You cannot deny later. Of course, the technical undeniability or the theoretical undeniability is drawn from the mathematical problems that these algorithms are based on. But the legal undeniability comes from the IT Act, right? So this secure dongle, is actually, if you think closely, it is what gives you the protection of what you have, the what you have authentication paradigm that we have. So you have the dongle. It means that you are holder of something, right? And the physical access of the dongle establishes this what you have constraint. And these dongles are electronic keys, which are also a very popular term used, a synonymous to these dongles, is what is used to build this multi-factor trust. Okay, so you can use it to prove your identity. You could use it to access something electronically, like accessing the private key in this matter when you sign a document, and you can again mix and match them to get a higher level of security, right? So what is interesting is that though the technical and the legal framework is all set, but where does the hardware for these dongles come from? And can we trust them, right? And I think this answer is known to everyone, that the international the chip market or the international inventory in terms of the supply chain that goes in terms of these chips coming from abroad, and then we are using them, or products coming in from abroad, they cannot be completely trusted. Not because we don't trust our partners, our trade partners, but because in the way the chips come in, they could be, tampered with either during the fabrication level itself, which makes our trust a big issue, and then also while in transit, right? So what we want to offer through the product that we have developed and is a solution to that trust issue that we have on a foreign made dongle, right? So and to be frank, the markets are flooded by by dongles by our northern neighbor, and these are dirt cheap. They will come in a few hundred rupees, and they serve the job, and they are FIPS compliant for that matter. They are certified, FIPS certified, which makes them more sort of at least perceives them. You will perceive them to be more reliable. Whether they're actually more reliable or not, that's a matter of debate, and perhaps the reason we are talking about the product right now. So the other thing that comes into the picture is whenever we procure this, okay, this leads to the trade deficit that we have with our neighbors, right? So the answer is, can we have an alternative? Can we do something that is completely made in India? Of course, the question could be raised that are we making the chips in India? The answer could be, yeah, we are in the process of doing it, but other than the chip or the secure element that goes into the chip, everything else can be actually assembled, made in India. And this is what we have done. The product that we have developed, the dongle that we have developed, the trust token that we call it, is actually a make in India product, and it is every aspect of it other than the secure chip that has to be, there's no other option, has to be procured from abroad. Entire the chip, the PCB assembly and the entire product is done in India, and our partners for the mass production is BEL, and CDAC and IIT Bhilai are working on it. And what we are offering is one of India's first indigenous secure USB dongle. The term secure is very important here. And another term that is very important is the operating system that goes into this dongle. Okay, so the operating system that goes into this dongle is actually Scosta, okay, which is an operating system that was conceived and designed in IIT Kanpur in Professor Muna's lab there, and since then it has been adopted as a standard of the Bureau of Indian Standards. It has been adopted as a standard, and this is what imbibes trust in it. Okay, so Scosta is the OS that is used. So the software part of it, the hardware part of it, except the chip, everything, and the entire assembly, everything is done in India. So this is what we are offering in terms of the trust component in it. Now I'd like to talk about some very interesting features of this particular product. The first thing is definitely that is indigenously developed, right? That is what imbibes trust in it. It is based on a standard, an Indian standard, hence the interoperability and the compatibility things are taken care of there. And as we mentioned in the title of the paper that we submitted, that we are actually developing what we call as an application security framework based on this dongle, right? One thing I would like to highlight here is that the private key that we are talking about never comes out of the USB token. This might seem like something that could be usual or something that is quite normal, but I would like to caution you that it is not. Most of the dongles that you get in the market, the ones that we procure from these vendors who would deliver them at the blink of an eye, these dongles actually do not support this. These dongles, the problem is these dongles, whenever you have the private key, you can actually download the private key in the dongle. There is a mechanism, there is a manager that allows you to extract the private key from the dongle as well as put it there. Of course, there could be variants that do not allow it, but there are variants that allow it, and most of the variants that are available, the one that you procure, maybe tomorrow you can try out. Doesn't cost much. You can try out. You can see once you have the dongle, there is a mechanism provided you enter the pin, which will be shared with you by the provider, the service provider. You can actually extract the private key and put it in your desktop. That defeats the very purpose of the thing actually. So here we bring in the Scosta OS, which doesn't allow the key to come out. So what we can say is, or what we can particularly tell is that this device has the private key generated inside it, it lives inside it and stays throughout its lifetime inside it. It can never be extracted. The interface doesn't allow the key to be extracted. Okay, the OS is a very stripped down version of what an OS we would like to think of through our regular perception of an OS. It's a very stripped down version, and it's a version that supports most of the operations that are needed. But this is one particular component or one particular, I should say, feature of our implementation, and the OS in particular. Due to the OS, this feature is due to the OS that it doesn't come out, and this gives us a lot of benefit in terms of the trust component. Again, since it can, no one, even the person who knows the PIN number, he can't extract it because it is not allowed to be extracted. Okay, so this is one thing I would like to highlight. Coming forth, if you look at all the different components of this project, of this product that we have developed, I would like to put up this pyramid layout, where we start with the secure dongle hardware. So herein it started with our chip selection. So we had this expression of interest going out, and there are many vendors, many leading semiconductor companies that participated, and finally we actually finalized 2 of them, which matched most of the required parameters, and also supported the USB interface, because it's a dongle, it has to support the USB interface. So this was the first part of the project, right? The second was the software that was to be developed, which had to be compliant to the SCOSTA PKI standard. So this was the part of the OS development, which was done by CDAC. CDAC is the owner of the OS code, and IIT Bhilai had supported CDAC in terms of the over review and overall functionality testing. And finally, what was important is to understand that we also brought in the support for elliptic curve cryptography. Okay, so the traditional or the classical version of the OS actually only supports RSA. So as a part of this project, IIT Bhilai led the team in terms of curve selection for ECC and upgrading of the standards, which is currently under submission to the Bureau of Indian Standards, to upgrade SCOSTA PKI to support ECC as well. And the implementation of the elliptic curve cryptography parameters was done with the help of the libraries that are provided by the chip vendors. And finally, at the end, at the top of the pyramid, we have the application framework that I'm going to talk about later in this presentation. So this is the entire structure of all the various components that were, that played a part in the overall building of this product. And I am very happy, and if you can see on my screen, I am showing you here itself in front of the camera. This is the product that we have developed, the image that you have. It's a prototype, of course. It's not a massively produced device, but it is there for the proof of concept, and we have been able to demonstrate all the features that we had claimed to be to incorporate in the product. In this trust token product, and we also have filed the trademark for the same. IIT Bhilai and CDAC Noida will jointly own the trademark for the trust token product. And now I would like to talk about the application framework, which forms a very, very important component of this token. The token, of course, as a standalone product, it is there, it can be used, but it becomes more useful when you talk about it in conjunction with the application framework that is developed, right? So some of the applications that I'm going to talk about are standalone applications. This means CDAC has developed softwares that you can install and use this through the dongles. I would like to make it clear that the applications that are developed are not the ones that are developed for the first time. Such kind of applications do exist in the industry and freely available also. But what we have designed is compliant to the token that we have developed, because the token is a very special one because of this restricted command set that it uses, which plays a very important role in the overall security claims that we have for the product, and hence these products make this dongle compliant to this. Of course, the dongle itself is compliant to the standards, which I'm going to talk about in a few slides from now, and hence it is easily adaptable for any systems. It's interoperable. It's not that it is not that it is very niche and it is only usable for certain circumstances. It has the generic support as well. So the PDF signer is a very important tool that we have developed, and actually I'm very happy to share that IIT Bhilai also has these digital degrees that it gives out, and it has its own software, and this PDF signer is being incorporated with that software called Radian for batch signing of digital thousands of degrees in very less time. And the second and very important component that we kind of advertise for our product is the VPN. So we all know that, even before the Corona times, VPN has always been a very important component in any organization that is geographically distributed, right? It's not that it just has one office. It has offices over the various places, geographically separated places. And VPN helps us to kind of give an abstraction that makes this geographical separation transparent, right? We don't need to care about that. I want to access a computer just a few meters from here, and I want to access a computer which is 500 kilometers from here. Essentially, other than the network delay, there's nothing making me aware of the geographical separation. So VPN helps us in that. And what we have done is that we have integrated the key derivation mechanism of the VPN with our dongle. So the dongle allows us to establish this VPN connection, and at the same time, it also establishes the identity of the person that has established the VPN. So we mentioned that it's a multi-factor authentication that happens. So the idea is once a company issues this dongle to a particular employee, and the employee uses the dongle to establish a connection from his home to his office computer, maybe, or from a remote location to his office computer, then the dongle allows us to establish who did it, and at the same time also allows us to manage the key derivation process and other associated things. Okay, so VPN establishment is not something very new. It's very routine. I think the previous speaker talked about VPNs, and we all understand what it means. The tunneling protocol, IPsec VPN or site-to-site VPN that we generally establish, and essentially it allows us to establish a private network or a private channel over a public network, right? The next thing was the e-office integration. The e-office integration is something that we are talking about with NIC. So e-office is one of the very important products, NIC, and in general, e-office, if we don't want to talk about e-office in particular, but in a generic sense also, it talks about any kind of ERP type of system which we use for a kind of a digital management of offices. And then we have the idea of password vaults, and finally I'll talk about the app framework as well. So the applications that I have talked about previously are kind of standalone in nature, but the application framework is something that we kind of deliver as a generic way of developing applications which are compliant to our dongle. Okay, so it's a framework. It's kind of, you could think of it like a mechanism to have an app store which of apps or web applications that are compliant to the dongle or that use the dongle. In terms of if I want to give you some details in terms of our OS, then these are the things we are currently supporting. It supports both RSA and ECC. In case of ECC, it supports NIST P256 curve. And if someone is familiar with the ECC literature, you would know that the curve selection is a very important parameter of the entire ECC jungle, if I can use that term. And in terms of RSA, the chipset currently supports 2048 and 4096, which is natively supported in the standards as well. And both our vendors, Infineon and WiseKey, actually have chips that support RSA 2K and 4K. So along with it, we have ECC. Now I'm again going into the details of the application framework. So these are the three basic verticals in the application framework. One is a remote authentication framework that we have developed. This can be used to authenticate anyone remotely. There are two things that are used. This RAF uses OTP to authenticate, something like you are holder of a particular mobile number and a mobile device, and along with you need to have the dongle. So dongle must be plugged in before you use the remote authentication web app, and along with it you have the OTP that comes in. So basically you register. You need to register first. When you register, your token is personalized, and your login credentials are put into the database. And then once after the registration is done, anytime in future when you want to authenticate, you just you have to plug in your dongle. Remember, if you don't plug in your dongle, the app doesn't work at all. The web app won't respond. It has internal services that run, which will see if the dongle is plugged in, and the dongle is the one that it claims to be. So you are entering the credentials for someone else, it doesn't work, and it will actually pull in your username and everything from the dongle itself. Next is the SKVPN, which I already talked about, so I'll not like to talk more about it. So when we talk about VPN, we are actually mentioning, because there are a lot of different types of way you can establish VPNs. We're talking about IPsec, site-to-site VPN. And the third is a very, very interesting feature that our product supports. It's called heartbeat checking, which essentially allows you to real-time monitor whether the dongle is connected to your laptop or not. Anytime you pull out the dongle from it, it will actually pull the plug. It's like pulling the plug. It will stop the web app. The web app will go away. The login session will end. Okay, so that's a real-time heartbeat checking that is done, and it is done through an indigenously. It's done through a protocol that is similar to something like a hybrid symmetric asymmetric mechanism. I'll not go into the protocol details because of the interest of time. And in terms of interface compliance, which makes our dongle globally acceptable for any, you plug it in any Windows or a Linux laptop, it should work out of the box. Is the adherence to these standards, PKCS 11, which talks about the crypto KI or the hardware token interface standard, and PKCS 7 it talks about the signatures that are used.
Dr.
So,
Saha,
yes,
Dr. Saha,
am I late?
Yeah. Can you conclude in 2 minutes, if possible?
Yes. I think I'll be able to conclude in 2 minutes.
Thank you.
So these are the final applications that are actually there. Okay, that we have. And as in the industry, I'm not going to go into the details, but just go through the screenshots of the applications. There are certain websites which you can access, but unfortunately, because you will not have the dongle, so you'll not be able to use these applications. You need to have the dongle. So I'm quickly skipping through the various screenshots of the applications that have been developed by CDAC. And this is the application which talks about the secure web app in terms of file retrieval. We also have a token manager that allows you to handle the token. And this is the VPN application. I'll skip it for the time being. There are many demonstrations that have been done over the time by both IIT Bhilai and CDAC. One of the thing is in NatGrid project, the identity workshop, and also at NIC and MITI. And this is the e-office and functionality which is currently under submission to NIC. And IIT Bhilai is integrated with the Radiant product. So this is the last slide I want to summarize that what we are providing is an extra layer of security. So for example, in case of a fintech application like an online SBI.com, what we'll offer is an extra layer, an extra web page that will come in. And whenever you plug in your dongle and authenticate yourself, only then you will move on to the main SBI web page where you do the actual net banking. So without the dongle, this page should not open. And we understand that we cannot disrupt what a particular bank is going today. So this could be provided as an additional mechanism of people who are more security, I should say concerned, or they have resources that are more security critical. Okay, and then once the dongle on the authentication is done, access is granted. So the road ahead for us is we have already, the product is already under final review by the ministry. And we are going ahead with the mobile version, so to be able to adapt it to the mobile platforms in a future project, again under review. And then we are also a part of the post-quantum PKI project where the dongle will be used. This is again under review, and this is backed by the control of certifying authorities. So thank you very much. I think I was able to conclude within the 2-minute constraint that was given. And the dongle will be available very soon. If anyone would be interested in looking at it, we would be very happy to demonstrate to you. Thank you very much again for giving us this opportunity and allowing us to demonstrate our work, which was done over a period of 2 years. Thank you.
Well, thank you so much, Dr. Dhiman Saha. That was an excellent presentation. I was actually listening very intently. I think this is great work with you and your team. I forgot to mention that Dr. Dhiman Saha is a faculty at the Department of EE and Electrical Engineering and Computer Science at IIT Bhilai, and he's done extensive work in crypto and cybersecurity for several years now. So I think it's a great talk. We do have, I see one question here that I'm going to read out. I have a couple of questions. So let me read out the question now that is showing up, which says, it's good work, but I think that the whole point that has been asked, Dr. Dhiman Saha, is
Right.
how will this ensure that the secure? How will this ensure secure usage when this is plugged in a vulnerable system? So when your dongle is plugged in a inherently vulnerable system, how are you going to ensure the overall security? That's a good question.
See, the idea is, you see, the dongle won't respond to, unsolicited requests. It will respond to requests only which it can recognize, and these requests will be digitally signed. So it doesn't respond to just any query. Okay.
Right.
So this is one thing. Another thing is, so when you are trying to pull up a site, which is compliant to this dongle, this site is supposed to talk to this dongle in the background, and only if it is able to mutually authenticate and it knows that it is a registered dongle that was given, only then it will give access to your next level of authentication. So in that way, it gives us a protection. Another thing I would like to mention is that the ability to have a physical restriction of this. For example, you want to do bank transactions at your home, and sometimes it might happen that someone in our house who is not very conversant, he is doing something and accidentally ends up spending money, right? So because I can now physically restrict the access of this dongle, I know that okay, dongle is in my in my closet. So okay, fine. Let my kid play with the laptop, and whatever he does, he doesn't have the dongle, so he can't do anything. He will not even be accidentally. I'm not trusting him. I'm telling he'll not be accidentally spend, or there should not be an accidental loss in accidental financial loss. So it is the interface of the dongle and very restricted command set of the dongle that gives a very important security. Along with that, every command that is given is authenticated actually. So any malicious attempt would not have the proper keys that are necessary to communicate with it, and hence they won't work. I think you are not audible.
Can you hear me now? Can you hear me?
You are on mute. Yes, you are on mute. Now I can hear you. Yes.
Yeah, thanks. Sorry, I'm saying thanks. Yeah, I think that question has been answered very clearly. So I have a couple of quick questions. Let me not take much time. Can you highlight the limitations of this product? I mean, your dongle has a very specific purpose, and I think that's very evident from your presentation. But any limitations that you may want to highlight in the dongle? Are there any scenarios where this dongle is not going to work? Number one. Number two, what are the possible vulnerabilities of the dongle? Are there any scenarios where this is going to be vulnerable?
No, not that we know of. So this dongle protects us against almost all known possibilities, known attacks. So one thing I would like to mention is, as you mentioned, the limitations. See, limitations are not, technically it is a compliant dongle. It should work out of the box. Okay. So it doesn't have any technical limitation. Now, if I talk about limitations in terms of newer algorithms, it supports ECC. Okay. Now there is a lot of interest in the industry about curve 25519, which is a important curve in terms of electric curve cryptography. Our dongle currently doesn't support curve 25519. Now, there are reasons behind it, why we don't support it, because curve 25519 has not yet been standardized. Though it is the most widely used curve, even the current stream that we are having probably is using it. The StreamYard thing probably is used curve 25519, but we don't support it. So I can call it as a limitation, but only because it is not yet standardized, which doesn't allow us to adopt it.
Yeah. But I think that's a matter of time.
That's a matter of time.
That per se may not be the limitation, because I think it's a matter of time when you may see that being standardized. Great. Have you people? I mean, this is, as I said, it's a great work. You have not filed any patent. I heard that you have a trademark. There is no patent filed in India and outside India.
No. We actually this this is a part of a established standard. The OS is a part of an established standard. So. No, we have not filed any patent, but the trademark we have filed. We have filed for the trademark so that in future when it is commercialized through any of the channels, it comes up. I would like to highlight that.
to be that the standard essential patents, the SCPs. This may fall into the category of the standard essential patents.
Okay.
So we may want to look into that, because I think there are
Okay.
there are a lot of ideas here that are under the umbrella, and I think you may look at SCPs over here.
Okay, thank you. I think that's a very interesting suggestion. And as I mentioned, one thing I would like to highlight that in future, when as a follow-up of this, we are currently trying to put it across for more advanced algorithms like quantum secure dongle. So that is what we are trying to make. This is the next level of for the project.
Okay. Well, very good. I don't see any other question here. Very good talk, Dr. Dhiman Saha. I look forward to meeting you in the near future, either at IT Bhilai or in New Delhi. But let's thank the speaker and all the, I know this is a paper along with Professor Rajat Moona, many other colleagues, Dhananjit Bagh, Aman Verma, et al. I will not be able to read all the names out, but let's thank all the authors of this lovely work, lovely paper. Please join me in expressing our appreciation. Thanks again. Thank you very much. Yeah, I think this work has great scope taking it forward, and I'm sure it will make in the cybersecurity world where you really want to have a PKI, hardware-based approach in trying to secure systems. So great work once again. Thanks again. I'm now going to, thank you very much. May I now invite the author of the second paper of the session. And the paper is titled Blockchain-Based E-Voting System in Indian Perspective. Again, a very exciting topic, something that we're all keen to learn about. And the speaker is Mr. Pragyan Jainmini. Pragyan is a fourth-year student at the School of Engineering, JNU. He's pursuing his bachelor's in computer science and engineering. He learned about blockchain and its affiliated products during the COVID lockdown. Interesting. A lot of us learned a lot that time. Majorly due to his interest in current affairs. Fascinated by blockchain technology, Pragyan has been working to contribute something substantial towards the electoral voting systems. Let's hear Mr. Pragyan Jaimini.
Hello. Good evening, sir.
Yeah, over to you, Pragyan. So you have 25 minutes for your presentation. Please, let's keep 5 minutes for Q&A. Over to you.
Is my slide visible? Okay. Hello. Good evening, everyone. Today, I, Pragyan Jaimini, BTech fourth year student from School of Engineering, is going to present a paper titled Blockchain-Based E-Voting System in Indian Perspective. This paper has been co-authored by Pushpak Prateek, Manish Kumar Saini, and Dr. Mukesh Giluka. Okay, so the major points of discussions of our presentation would be that what is the need of alternative systems, the considerations or the constraints we had to overtook while designing the model, the literature survey we undertook every time we were designing this model to get a better idea of what is currently happening in this scenario. Further, we would work on to the overview of the model, system requirements, and some results which we have found until now, and what would be the way forward of this paper, and at the end we would give some concluding remarks. So before actually putting forward our e-voting system, we would like to discuss what actually was the need of an alternative system. So the election process in the country has been one of the most sacred processes. Despite our differences into religion, caste, gender, or anything, what keeps us united is the trust on the electoral system. Currently, the voting system is based on an electronic voting machines called as EVMs, which had been started from an Kerala by-election in 2004. These EVMs had taken place of ballot paper, which started as soon as we got democracy in our country. In this fast-moving pandemic world, when everything has gone online, just like this conference, there must be some changes incorporated into the current system to keep up with the pace of the time. So the following 4 reasons which we found were one of the essential reasons why there was a need of change in the system. First was there are a lot of people who are NRIs, there are migrant laborers and students who are living far away from their native lands or at the places where they have their voting rights. These people cannot very frequently travel to the place where they have their voting rights to participate in this festival of democracy. Next, there are patients who are medically unfit and advised by the doctors to keep up complete bed rest. Though there is a system of postal ballots, but not every patient is allowed for such special scenarios. Next is, as there is a huge amount of trust of the people into the election process, the system needs to be keep evolving itself so that the trust can remain maintained in the society for this election process. At the end, as our Prime Minister says, Digital India, so as to enhance the digital revolution in the country, we would need alternative system other than the existing system where we have to go to some designed places to vote. The constraints which we undertook while designing the model were, the first was that the voting process which goes on must be transparent and be based on claims which have some strong and verifiable proofs. It must not be some haphazard manner process which might cause mistrust among the masses. Next, whatever vote happens, it must be permanently casted, and the choices of the voter must not be deleted or be altered in any scenario. Next, the system must ensure a secure authentication process along with safeguarding the voter's privacy. That is, any of their personal details must not be leaked out to anyone who is not actually into the system. Further, there must be a strong user verification process which must be deployed so as to ensure that only the correct user has entered and he is voting for only pre-designed constituency he is into. Further, the servers must be capable of handling data and certain surge of voters over a large scale, because we know that the election process takes place for a limited amount of time. So it must not be a scene that when the voters are voting, the server might crash or anything wrong may happen which might cause disruption into voting. That further, the choices of voters must not be traceable under any circumstances. There must exist no scenario in which a voter who has chosen any particular party, his choices must be leaked into public, or anyone in even in the system got to know that he has selected some particular choices. Voting frauds such as multiple voting, proxy voting, and some scenarios like booth capturing sort of, which used to happen during ballot paper era, and sometimes we get to hear them about the electronic voting machine era also. These must be avoided at any cost. So the model which we have put forward actually works on to handle all these considerations while it has been designed. We undertook we undertook a lot of literature survey so as to make sure that our voting system is up to date and takes help of other existing papers to improve our system which we have put forward. Overview of the model's prime technique is decentralization. The model works on to exploit the model works on to exploit the entire scenario of decentralization so as to make sure that whatever the case may be, it I am audible, I guess. Sorry. The model works on to exploit the decentralization technique so to make sure that the choices and whatever stuff which is going into the server remains tamper free, and no one inside or outside the system must be able to hamper or change this whatever thing has been once put into the server. We would be using Ethereum based private blockchain technique so as to make sure that only a limited amount of nodes get an access of the server, so that the public blockchains which are vulnerable to 51% attack, this cannot take place into private blockchain scenarios. There are the following six major technologies which we have used while designing this model. The first is blockchain, as I had already discussed. It is to basically to decentralize the voting process and store data. Next would be convolutional neural networks. It is being designed to detect human emotions such as joy, sorrow for authentication that the only designed and the correct voter has only logged in. Further, we had used an hash method authentication code algorithm. It is being used to generate OTPs with along with timestamps so that the OTPs might expire and it cannot be misused over a long duration. Next, we had used a Django framework which has been used to facilitate the authentication process from database using APIs. Also, we would be using the non-fungible tokens to store the image of the voters. SHA-3 algorithm has been used to create hash value of the vote which would be polled. So can I zoom it? One second. So this is a voting process. As soon as the user enters his Ethereum ID, he is sent an OTP on his phone. After entering his OTP, the user is logged in into his, the OTP is incorrect, he is asked to log in again. As soon as he is logged in, there are two different parameters which we have worked upon. The first one would be he would be given some data access which would have some past election results, upcoming elections, and also he can verify some voting tokens which has been generated. Through this we can make sure that only accurate voting tokens has been generated, and also this will help to generate trust among the masses that whatever voting tokens which are being generated are being recorded. Okay, at the other scenario, when the voter decides to vote, the app which we have designed will ask the voter to switch on their front camera in their mobile phone. As soon as their front camera is switched on, the app will capture an image of them and match it with the non-fungible token image which has been already stored into the server. If the image isn't matched, the voter is automatically logged out. After the image is matched, our convolutional neural networks will detect the emotion which is present into the captured image. If the image would have a higher percentage of fear and its related emotions, our system would automatically log out the user. In case the image has a low quotient of fear, the voter will be allowed to vote and a voting transaction would be generated. The only reason why we have put this convolutional neural network to detect higher percentage of fear and in its related motions is there might be scenarios where people are being forced to log in and to vote for a particular candidate. So if our systems are able to detect such kind of fear and its related emotion, they will automatically be logged out from the server, and the entire process would have to be repeated again. So the Android app which we are in the process of developing would work on to the following system requirements. It would require an Android operating system over in 7.0. It would need a RAM of at least 2 GB, memory space of at least 100 MB, of free memory space of at least 100 MB or more, a functional front camera, and an internet connection. So some of the results which we had got after we were using convolutional neural network to detect the human emotions. The right image which I am pointing on is the stored image of a user, that is mine, and at the left is a captured image. So our neural networks had detected that it had around like 45% of happiness, 28% of neutral, and other emotions respectively. So as there were a low significant percentage of fear and its related emotions, the access was granted to a user to vote. And in the next scenario, when the captured image looked like a person of very dull mood or scenario, it had detected around higher percentage of fear and its related emotions. If you would look out, the access was denied to a voter to vote. This was to make sure that the voter isn't under any subdued pressure by some particular or external agents who are trying to hamper the process of voting. Okay, so overall results which we have found, the app was used to automatically log out the user as soon as fear emotion and its related emotions were crossing 70%. This all was basically to indicate that the user is in a state of fear. The accuracy of emotion detection has been currently over 83%, and we have been using different data sets like Flickr faces headquarter dataset and UTK face dataset. We had also used eigenface model, but we found out that convolutional neural networks were more accurate in detecting human emotions. At current stage, we are able to allow approximately 10 users to vote at the same time. The voting tokens which are being mined are being successfully verified into a portal, and as when they are put on for mining, the following things are displayed to a user. The first is the timestamp, that is at what time this token has been generated. Next is the block ID, and the third is the hash value of the token. This hash value has been generated when we use SHA-3 512 algorithm. So the way forward to this process is that this has been a work in progress model. We had not entirely completed this work, and we are progressing more into this. The three major portions which we are working upon currently is improving the user's photo authentication process. This is to make sure that a system accurately detects emotions and there isn't inaccurate logout of a particular user. Further, though the entire system is being working on a blockchain, we are still working on to enhance the security of the servers which would be storing the votes and NFT of the images. The third and the last is that we are working on to increase the amount of voting transactions per unit time, so that it can so that a system can be expanded over large scale. Concluding remarks. Currently, online voting systems are currently in a very dormant stage, and it's a very long way before they replace the current existing systems. Trust, which has been one of the key parameters on which any system across the world can sustain, e-voting systems can only become a mainstream, which only if they used several technologies to build trust and bring transparency into the systems. Our paper has attempted to propose a model while trying to address some of the concerns which people have currently regarding e-voting systems. The data decentralization process is the thing which our paper has aimed to exploit and provide each one of us a reliable method of voting. Thank you. I have completed my portion. Any questions?
Yeah, hi. Thanks. Am I audible,
Yes, sir.
Pragyan?
Yes. Yes, sir.
Yeah,
You are
thanks,
audible.
Pragyan. Rajiv here. Thank you. That was an interesting talk. Very impressive. You're in your fourth year of undergrad, and very impressive work that you've done. I think it's also very timely and a very important piece of work, quite like the talk before you. So, congrats on thinking through all these ideas, because coming out with a robust e-voting system in the Indian perspective, where scalability is a big issue, reliability, scalability, accuracy is a big issue, as you are very aware, right? I think it's
Yes.
quite a challenging problem. So thanks again for your talk. There are no questions that I see in the chat window. Maybe I'll ask a question if that's okay, Pragyan.
Yes, sir. Yes, sir. You can ask.
Yeah. So I think, as I said, excellent work. How do you think? So I think a couple of extensions you mentioned, right? One is scalability, right? Currently, your system has a limit. How do you think you'll address that scalability? Any thoughts on how will you do that?
Yes, sir. First of all, when we want to expand our systems into Indian perspective, we have a very limited amount of users who are having an internet connection. So basically, a stable internet connection. So First of all, we have to work on to provide stable internet connections across the country. For that, we can use some satellite-based internet companies, like currently Bharti Airtel is working with OneWeb to provide satellite-based internet, and Starlink of Elon Musk is also working into the same direction.
Right.
Through this, we can work on to provide stable internet connections even in hilly areas and areas through which we cannot provide internet connection in towers. This is the first thing. Second thing is that we have to work upon to increase more number of nodes into the system. That is, we would need more amount of servers so as to help expand the system, and more amount of voting transactions can be generated in per unit time.
Right. Yeah. I think the system, there are inherent limitations, but you're saying assuming I have good bandwidth and connectivity, my system will work, right? Yeah.
Yes, sir.
Sure. What else? Any other? Where do you think? What do you think are the vulnerabilities here? What do you think are the limitations over here?
So first of all,
the technical limitations here.
Yes, sir. So the first technical limitation is that we are still unsure about how, like, we would be providing Ethereum wallets to everyone, like basically an Ethereum ID. This we are only providing so that the existing system has some recorded what we call it is on sequence, but through Ethereum IDs it won't be a sequence. Instead, it would be random addresses, so that we can you just am I audible?
Yeah, you're audible. Go ahead.
Achha, okay. So the first vulnerability is providing an Ethereum ID to everyone. This can, because we would need a lot amount of Ethereum to be, means like it would be a lot amount of money to be generated, because each one of us would have to be given some Ethereum wallet. Next would be, the major issue is that we have to scale it at a very large scale. And if there is an external DDoS attack, that is denial of service attack, it might be very much possible that the servers might get in disruption and voting process might be hampered. Right. So currently, these are the two technical vulnerabilities we would be working upon too.
Yeah, I know. So you'll have to look at these attacks, potential attack sources carefully, right? Yeah.
Yes, sir.
Yeah, because there could be many attack vectors which you have not thought through. Worth looking at what they are and try to address at least the main one, the key ones, right?
Yes, sir.
Okay, I don't have any other questions in the chat window. So thank you, Pragyan, for this talk. I have one more question. Are you not planning to file a patent on this work?
Currently, sir, we are working on to show our prototype to our professors and get their comments. After that, we would be working upon to this step.
Yeah, I think this is definitely worth patenting. Please think about it. You want to discuss this with your supervisors, right?
Okay, sir. Thank you, sir.
Great. Thank you, Pragyan. Thanks again, and good luck. Wish you all the best for your future endeavors.
Thank you, sir.
Thank you. We'll move on to now the last paper of the session. The paper is titled Dynamic SLA Using Smart Contract for Terrestrial and Non-Terrestrial RAN Leasing, and the speaker is Mr. Aman Khan. The paper is co-authored with Aarti Dhiman. Mr. Aman Khan received the Master in Computer Applications degree from the National Institute of Technology, Raipur, and is currently pursuing PhD from IIT Bhilai. His research interests include 5G networks, non-terrestrial networks, application and challenges in integrated satellite terrestrial networks. I'm going to request Mr. Aman Khan to please present his work. Thank you.
Am I audible?
Yes, please go ahead.
Okay. Good evening, one and all, for giving the chance to present my paper over here. Kindly acknowledge if the screen is visible.
Yeah, the screen is visible. No, not yet. Just share the screen. Not yet. I can hear you clearly, though. Aman, you have 25 minutes, and we'll leave 5 minutes for Q&A.
Okay.
So please share your screen. Yeah, I think it's coming up.
Is the screen visible now?
Yeah, just give a few seconds. It's coming up. Yeah, perfect. Go ahead. Over to you.
Okay, good evening, one and all. So presenting the paper with title, Dynamic SLA, service level agreement using smart contract for terrestrial and non-terrestrial RAN leasing. I am the author of this paper, and the co-author is Aarti Dhiman. We both are from Indian Institute of Technology, Bhilai, India. So the outlines of the paper includes the introduction regarding the dynamic SLA and its usage in the scenario of integrated or terrestrial and non-terrestrial networks, the motivation of using blockchain to RAN leasing, and the background of blockchain and smart contract along with the service level agreement lifecycle, the approach to solve the problem of dishonesty occurring in RAN leasing area, and the evaluation of the work, further the conclusion and future works and the references. Moving to the next slide. To introduce the paper presents a solution to risk management where we are deploying a service level agreement on smart contract. Service level agreement considers a scenario where an integrated satellite and terrestrial network is there. So here what we are doing, a radio access network provider leases the satellite payload or 5G or both to mobile network operators. As we know that the era of 5G has higher and dense network connections, which leads to deployment of large number of base stations as well as satellite payloads. And the deployment is near about much more costlier. So the solution, the possible solution is to take the GNBs on lease, and when taking the GNBs on lease leads to some of the risks whose management solution, one of the risks whose managed solution is provided by this paper, and both monitors, the paper monitors the throughput violations happening between the radio access networks and the MNOs. Automatic penalization and payment is done by the smart contract as well. The motivation is like in traditional SLA, service level agreement, both the parties have to trust their monitoring solution. Whereas in proposed scenario, MNO might not trust the RAN provider's monitor, or similarly, RAN providers might not trust the MNO's monitor. And as a solution to solve this problem, there is a need of one relationship which both the parties can have total trust on. So here in the diagram, we can clearly see that the current trust relationship is like the service provider and the customers have to authenticate or have to have a trusted third party to authenticate themselves. An SLA is signed in the presence of the trusted third party. And to monitor the SLA, both the parties have to have a monitoring solution of their own. But still in that case, there is a chance that the one party cannot trust on the monitoring solution of the other parties and vice versa. Whereas we can see in option B, the approached trust relationship presented by us, where a smart contract is deployed between two parties to generate a relationship of trust, because as we know, the smart contract generates trust and is immutable, and a single trusted monitoring solution is deployed, trusted by both the parties, to generate a trust relationship between them. Coming to the background of our life cycle, of our approach, the SLA life cycle, the service level agreement life cycle, starts from the discovery phase, where the discovery phase starts by locating the providers as part of the need of the customer, and basis of the need of the customer, we locate providers. And in the defining phase, we define SLAs, which ensure some quality of service matrices to ensure the SLA. In the establishment phase, SLA is established and the parties are ready to commit to a particular agreement. Whereas in monitoring phase, we can see that the monitoring solutions monitors if any kind of violation happens throughout the life cycle validity period. And coming to the penalization and payment phase, if any kind of penalty happens due to the violation of SLA, the penalization action is taken and penalty amount is penalized to a particular party and compensation is provided to the another party. And at the end, the payment is done. And after the validity of the life cycle, the SLA is terminated in the termination phase. Similarly, when we talk about the background of blockchain and smart contract, then blockchain is basically a distributed database that contains a record of all the transactions executing in a particular network of blockchain. It is a collection of blocks in order and identified by a cryptographic hash referred in the form of chain. Each block contains some transactions which can not be changed once deployed. And blockchains are mainly divided into two types, the public blockchain and private blockchain, where the public blockchain is accessible by each and every user and readable by each and every user. Whereas when we talk about the private blockchain, there is a authority which allows any of user to access the blockchain. And the blockchain used in this work is basically the private blockchain authorized by the mobile network operator. Coming to the smart contract system, the smart contracts are a part of blockchain, which is nothing but a part of executable code running on the top of blockchain to carry out some agreements. And it automatically executes the terms of that agreement. It is a more secure option than the traditional one, the paper-based service level agreement. And it has some unique address and can be run by sending transactions to contracts address, and based on that the storage and the account balances get managed by the smart contract itself. Coming to our approach, the paper focuses on the upcoming heterogeneous integrated terrestrial and satellite scenario, where there are number of base stations in the ground and satellite payloads on the space. And the integrated scenario says that both should work together, and MNO can handle both the GNB as well as the satellite payload. And here, mobile network operator provides service from both terrestrial base stations, including number of small cells, and also from the satellite clusters. So the MNO, for effective cost efficiency, leases RANs from RAN providers. So there is an authority, or I should say a party RAN provider, which have their own base station or maybe the satellites, to give the satellites or base station on lease, which acquired by MNO to fulfill the requirement of the users of that particular MNO. The service level agreement here is dynamic, and the monitor authenticated by both the parties will count the throughput violations and return to smart contract for every penalization period. Here we can clearly see from the flow chart of proposed dynamic SLA management that two entities are there, the MNO and RAN provider. In between them, there is a monitor and there is a smart contract. So to start a service level agreement, the MNO first initializes the SLA and the RAN providers verifies, checks the SLA. Then the registration of the provider is done at the smart contract level. The registration of the monitor is done, and same registration will be done by the RAN provider also, because the monitor is a trusted solution verified by both MNO and RAN provider. And as the validity period after the successful registration of monitor starts, as it is a prepaid solution, so the MNA deposits the prepaid service charge, and as the service charge is paid, the validity period starts. And in every compensation period, if any kind of violation happens, the monitor will report the violation to the smart contract, as well as the RAN provider will check if the violation has happened and actual or not. And if it is double checked by both of the solutions, then compensation is paid back to the MNO. Similar thing happens to the entire compensation period and till the validity period ends. So here what we are doing, the validity period entirely is divided into a set of compensation periods, and at the end of compensation period, the amount is transferred back to the MNO. And at the end of the validity period, the required and the left amount, the left amount is transferred to RAN provider as the remaining balance. And the further in continuation to the approach to calculate the penalty to be deducted, here we have taken variable P, which is nothing but the amount of the percentage of the penalty should be deducted from every at every compensation period. So here are various thresholds which we have taken, like if the threshold value is from 0 to some of the particular value, we should not deduct, because it is quite obvious that this amount of violation can be tolerable. So from 0 to that value, there is no penalty deduction. And P1 is the penalty if the violation goes from a particular variable phi1 to phi2. Similarly, in P2, if the violation crosses phi2 to phi3, if the violation is between phi2 to phi3, we deduct the percentage P2 of that particular amount, and afterwards P3 otherwise. The TV threshold value is computed using the formula summation of violations in seconds and divided by the entire penalization period, which is also in seconds. Whereas P penalty, the complete penalty value, is price of that particular SLA in that validity period cross penalization period divided by the SLA validity into the percentage of penalty deducted from the above equation. To evaluate this formulation, the evaluation parameters, simulation parameters have taken, where we have some time units, some threshold values taken, phi1, phi2, phi3, some penalty values taken basis of that threshold values. SLA validity for simulation is taken 30 minutes, and penalization period is of 5 minutes, and SLA price is taken 30 way, that is nothing but 30 into 10 raised to power minus 18 ethers. Further, the graph shows the balances of parties during SLA validity. So as the SLA starts until the end of the SLA validity, the balance of the MNO first raised down or started from a particular point, and as the penalty is acted on that particular SLA and compensation is given back to that MNO, the prices of that, we can clearly see the prices of that MNO or MNO balance is slightly increasing, whereas the contract balance is slightly decreasing because of the penalty. And at the end, the remaining balance is given back to the provider balance or to the RAN provider. Further, there are two graphs. First represents the penalization period versus violation. In every penalization period, how many violation in percentage has been taken. And the second graph shows that for every penalization period, how much penalty in way has been deducted from a particular smart contract. To conclude our paper, the paper has proposed a dynamic SLA for continuous monitoring of throughput violation and automatic payment in integrated satellite terrestrial scenario. The SLA is implemented in Ethereum on Remix platform, which supported multi-layer and multi-threshold based penalty to manage violations. Simulation is done based on assumed parameters, and graphs related to that are presented. This work could be extended as a future work to incorporate a monitors in smart contract, which would further reduce the need of trusting the monitor. And at the end, the similar SLA could be designed to enable an MNO to interact with multiple RAN providers. These are some useful references. Yeah. I'm done. Thank you. Any questions?
Thank you, Mr. Aman Khan, for a nice talk. Very interesting talk. Pretty,
Thank you very much, sir.
it's a challenging problem, and I think you have interesting results. I don't. So thanks again for your talk. I don't see any question in the chat window. Would encourage the audience to please post questions in the chat window. While they do that, I probably will start with one question.
Okay.
So my first question, your metric is throughput, right? You're trying to figure out throughput violations. You're trying to, right? You're focusing on throughput violations primarily, right?
Exactly.
What about if I add other metrics? Because in this context, in the terrestrial and non-terrestrial array and RAN leasing, you could have other metrics, right? you could have
Yes,
latency, you could have a fairly, other relevant metrics. How would you proceed beyond throughput to the other metrics?
Sir, as this is the intermediate work, and we are currently working on this. We can add, as you said, there are many metrics we can add, like latency and all. But overall, when we talk about a particular throughput, we can compute the throughput using particular latency or bandwidth and all. So, in a way, it is a complete, what I should say. It is, I mean, without a proper latency, we cannot conclude to a throughput. So yes, as you see, as we have computed throughput, and this for throughput violation, we can do the same for latency and other violations as well. But throughput can contribute, and it covers overall requirements like the other, as you said, the latency and the other parameters also.
Sure. Yeah, no, I mean, I think the work is very good. I'm just saying that one can add additional metrics over here.
Yes, definitely.
So that's going to be interesting. What is the? How do you? What do you think are the limits of your system, of your work? Where do you think it needs to? I mean, if, for example, accuracy, or where do you see yourself there?
Yes, sir. When we talk about the limitation, one of the limitation is that till now we have not put our monitor in a particular smart contract. So we are assuming that the monitor is a trusted device or a trusted sensor, which is trusted by both the parties, like the MNO and also from the RAN provider. But in future work, we are going towards putting the monitor also in that smart contract, or in a way like monitor is providing input to the transaction in the smart contract, so that we can assure that the monitor is now secure and can be trustable by both the parties. Along with that, one of the more limitation of this work is we have done this SLA between two parties, where one MNO can have a relationship or can lease RAN from one or more than other RAN providers as well. So to scale it is also one of the challenge which we are focusing on.
Right, absolutely. So I think you've already addressed that. That was my question about scalability. The other last point I have, I don't see any other question in the chat window before I hand it over to the organizers. My last question is that from the point of view of cybersecurity, you may want to look at how robust your system is as far as cybersecurity is concerned, because it's really an end-to-end system, right? You'll have to see what are the potential vulnerabilities. Now, I know that's a different aspect, but you may want to just look at that.
As of now, it is a different thing, but yes, we will surely look into it as well.
Right, because with that, you really have a very robust solution, right?
Yeah, exactly.
Resilient to failures. Okay, great. Thank you so much, Mr. Aman Khan. I think this brings us to the end of this session. We had three very interesting papers. I personally enjoyed all the three presentations. I think they are very important areas, and I'd really like to congratulate the chairs of the conference. Professor Rajat Mona is one of them, and many others in the committee. I think we have some very applied work. The work is current and applied and has great potential for filing IP, not just publication, but even I think there's an IP in all the areas that were presented today. So I think there's a lot that we look forward to coming out from the authors in the near future. So again, Mr. Aman Khan, thanks so much. With that, I'll conclude this session. Thanks to Dr. Dhiman Saha, Mr. Pragyan Jaimini, Mr. Aman Khan. I'm going to request Dr. Anand to please take over from me now. Thank you all so much.
Sorry, I was on mute. Thank you, Dr. Rajesh Shaurya, for taking out time from your busy schedule and for chairing this session. We are about to reach the end of the conference, and I would now invite Dr. Jayjit Bhattacharya to give the concluding remarks. Dr. Jayjit Bhattacharya is a noted expert in digital policy and president of Center for Digital Economy Policy Research. He is also the founder and CEO of CardsPay. He is also in the governing academic senate of IIIT Raipur. He has over 25 years of experience in digital policy and in deploying large-scale systems. He has authored 6 books on e-governance, and his first book was released by then Honorable President of India, Dr. Abdul Kalam. He has authored numerous peer-reviewed research papers. He also has patents in the US and India. He is BTech from IIT Kanpur, MBA from IIM Kolkata, and PhD from IIT Delhi. I now hand over the mic to Dr. Jayjit Bhattacharya for concluding remarks.
Thank you so much, Dr. Baswade. I think we had an excellent session today, and most of the key issues of internet governance got covered. I think it was an eclectic set of issues that were discussed today. Just going through the set of issues that internet governance really occupies, and internet governance as an area itself is hardly a 2-decade-old area. In fact, I started offering the courses on internet governance only in 2012 at IIT Delhi. So that's how recent the issue of internet governance is. And from the perspective of countries like India, there is an issue of also having sovereignty over the internet. Are we able to ensure that India has an equitable access to the internet, and also have an equitable access on an assured basis, which is that in future, if there is some condition that crops up, will India be able to continue to access the internet, or will there be threats that will be issued? As a very good example, usually when a war happens, before the war, it's an air force which comes in and degrades the infrastructure of the adversary. But when we had the Russians invading last year in February 24th, it was January 24th, on 23rd, there was no air attack. There was actually an internet attack that happened. There was a massive cyber attack that happened. Now imagine if Russia had the ability to control the 13 root servers, and they would go ahead and delete the Ukrainian TLDs, the top 11 domains, which is .uk. It would have a significant impact on Ukraine's ability to respond. Similarly, in such situations, if the .in domain is deleted, it will have a significant impact on India. And therefore, the issues of internet governance is not just about how the internet has to be accessed and how we need to look at trust and access and security and privacy, but also the geopolitics of internet. I think those are issues that do need to be touched upon as we move forward and do need to be researched upon. There are obviously also issues around intellectual property, around regulating the use and protection of copyrighted material online. The challenge happens when we start having digital being inserted into a fabric that has already had kind of stabilized. So we had kind of solved issues before digital came in, before internet came in. But because of the acceleration of any process due to the injection of technology, the fabric of regulations and fabric of social stability starts getting ruptured. One of the examples I can take is that under the Revenue Act of 1860 something, all the land records are public records. And that is how it should be, because how will you know what land that you're buying? So if there's a piece of land that you have the right to go and check who's the owner of that land, and therefore you can buy from that owner. With technology, what happens is you can reverse that query and you can say, what all lands does this person own? Which completely changes the framework in which we operate, because suddenly you can find out all the property that this person has, which can have a very harmful effect on this person. And this has already happened in our country, where people have gone through the obituaries, picked out names, and then gone ahead and figure out from our systems as to what all property this person owns. And if their children were not in Bangalore, these are cases from Bangalore that I'm quoting. If the children were not in Bangalore and were working in US, then their property was usurped and through certain frauds that happened. Now imagine if this person was not dead and was alive, and that would have very significant impact on the person itself. And therefore, many of the regulatory structures that we're looking at around internet governance also needs to change. And they need to evolve as we move forward. Similarly, the issue of cybercrime, much of the harassment of women happening in Lucknow is happening through the cyber route now. So, as per the data that we have, over 80% of the harassment of women cases is happening online, and therefore the way to prevent it and the responses again have to change. And therefore, these are issues that needs to be looked at in the context of internet governance. Similarly, the issue of digital divide, internet fragmentation, which becomes a very significant issue because we don't want the internet to be separated from campus to campus, from country to country, and so on and so forth. That loses the significance of internet. The whole purpose of internet is that every part of the world is connected. But if there are nations who would like to build walls and say, this is my internet and I don't want people to breach it, or I will only selectively say where people from outside can come in and how my people can go out in the electronic domain, that leads to internet fragmentation, which is not good for the users of internet. We also have issues around Internet of Things, which includes the issue of the security and privacy issues that arise from the proliferation of connected devices. As we know, we've got the shoes getting connected, we've got the heart and devices embedded into the heart, which is getting connected. And then there are also interference happening between these devices, and also, as we said, the issue of privacy. Because if you can find out what is the IoT in your heart saying, you're getting very fundamental information about my health, and that's a very severe privacy violation. How do we ensure that we take care of such issues as at an explosive rates, IoT rides on top of the internet and is spreading all over the place? There are also issues of satellite connectivity that we need to resolve. Satellite connectivity for internet will be a game changer. How do we ensure that that again there is equitable access and there is a low-cost access for satellite? And lastly, as I mentioned, the sovereignty issue on all of this. We need to ensure that that nobody threatens us once they provide the connectivity. Again, the Ukraine war is an excellent example where a private company actually threatened that they will take away the internet, the satellite-based internet from a country which, because of the fact that it's war ravaged, did not have much of an internet that it could use, and therefore satellite connectivity was very, very critical. Now, at a time when war is going on, if a company comes and threatens that I will take away the connectivity, then obviously you don't have sovereignty over over the connectivity. And that's a very, very serious issue that we need to look at. Today, we were able to go through the challenges of blockchain-based e-voting. We heard very deep research coming from Aarti Deman and Sauradyuti Paul. We also went through the paper on internet access artifacts and balance between regulations and privacy, a threat intelligence perspective by Maruti Shashidhar, Inukondo, Bhimaraja, Reddy, Tamma, and Sparsh Mittal. We also went through the paper of Trust Token Secure Application Framework based on indigenously developed PKI hardware token. It was extremely interesting. I hope that that paper is actually converted into a product. The paper was written by Dhiman Raja, Rajat Mona, Darunjit Bagh, Aman Verma, Savita Kashyap, Manish Verma, Brahmanand Prabhu, Adarsh Pillai, Aditi Kaushik, Ayushi Chaudhary, Venkata Saiteja, Anindya Ganguly, and Satanu Maiti. We then went through a second paper on blockchain-based e-voting system in Indian perspective, which was authored by Pragyan Jaimini, Pushpak Pratik, Manish Kumar Saini, and Mukesh Kumar Giluka. And then we had the last paper on dynamic SLA using smart contract for terrestrial and non-terrestrial RAN testing, which was authored by Aman Khan and Aarti Dhiman. We also had a very insightful talk by Dr. Subhi Chaturvedi on rebuilding trust in the digital age, strategies for ensuring integrity and transparency in internet. So we had a very useful session. I personally learned a lot from each of the discussions that happened. And I would therefore also like to thank Professor Hazur Saran and Dr. Rajiv Shori, both are very old friends of mine, who were kind enough to session the two chairs on the two sessions. I would also like to thank Professor Rajat Moona for being the conference chair, and Dr. Anand Basware, who actually did the heavy lifting for this particular conference. So thank you so much, Dr. Anand Basware. And finally, I would like to thank Mr. Anil Jain, who is the CEO of Nixie and also the chair of IIGF, for enabling this conference to happen. So with that, I would like to close this session. Thank you so much.